Everybody, sorry for the late start. As I mentioned in chat, the wake up music is copyrighted, and so um, I was able to go in and basically let YouTube just mute. Actually, I'm not sure if they muted the audio. Well, I know they muted the audio, but they may have just chopped those wake up calls completely out of the live stream. So uh, it is what it is. It's not a critical part of the flight day. So we're looking at a live view, very similar to the scenes that we have been seeing for the last couple of days. In this case, Orion is getting farther and farther away from, in this case, the crescent Earth, and I just this morning I did a relatively short live stream, and there is going to be a little bit of ducking in and out. The mission status briefing / news conference is going to be around 2:30 p.m. Central, 3:30 p.m. Eastern. That's only about 2 hours from now, and so I'm going to have to head back over to the Space Center in a couple of hours. And I went over to, I was over there earlier this morning. They gave us about an hour in the observation room above the mission controls, the specific flight control room in the mission control center. This is the Orion flight is being controlled from the white flight control room. And so I'm gonna at some point here take a little break, and maybe when commentary comes back up, and I guess I'll go ahead and unmute that, because I'm not expecting any more copyrighted music during this. But we got a chance to go in and look at what's going on, or what was going on the Orbit 3 shift, the overnight shift, and that flight control team may have played the wake up music, and then they will do this shift handover from Orbit 3 to Orbit 1. But there was some interesting things on the displays. We got a chance to go into that same room that overlooks the white flight control room back in September, but on that day they weren't doing the mission, but they weren't doing a simulation, I don't believe. I think they had started something so that it was driving the displays. But this was interesting because this was live data from a real current mission. So I'll see if I can find some images that show the displays. I think got a couple of quick glimpses of those displays. From time to time they'll show that, but they tend to fall back on the public real-time tracker. And I just went over early this morning when I tried to pull that up in the browser here on this beat up old laptop. The laptop was not happy, so I just took a quick screen grab of this. And so this is, I don't know, this is maybe 10 minutes ago, but this gives you an idea about where Orion was about 10 minutes ago. The velocity relative to Earth continues to slowly go down. This orbit that they're in, or this trajectory that they're in, is going to be, they're going to get a little bit of a slingshot from the moon, but you can see the moon over here. So basically both the moon and the Orion are going to arrive in the same general part of the moon's orbit at the same time on Monday. And so we can see Orion's about 100,000 miles from Earth, but still, I'm assuming that the 161,000 miles refers to the distance to the moon's orbit rather than the direct distance from the moon to Orion at the current time. It's possible, though, it's the other one. But I think as was mentioned either in the stream last night or maybe this morning, the crew is constantly breaking the post Apollo 17 distance record. Obviously, those Apollo crews back in the basically 1968. So Apollo 8 through Apollo 17, all of those missions made it out to the moon. It's just except for Apollo 9. Apollo 9 was a low Earth orbit mission, but those Apollo missions, almost all of them went into lunar orbit, with the exception of, again, Apollo 9 and then Apollo 13, which had the accident on the way out there, and they actually flew this type of a trajectory. So I am getting some reservation updates as well. So that was the other thing I'm adjusting my reservations for a little bit of the behind the scenes stuff. So one of the interesting things, and so we will have, I'll go ahead and take I'm going to go ahead and, so you can clearly see the NASA logo. Not really, but one of the interesting things in the flight control room was, and I did not pull up the YouTube feed, but there may be something in between the raw feeds that they're getting from the spacecraft and the feed that gets all the way out to YouTube. Because we were seeing some things, but I guess I'm not sure we're getting the exact same thing from, that it gets all the way out to YouTube. I'm gonna. I think the stream here, I may need to speed it up. Oh, okay.
One burn, outbound trajectory correction 1. That's slated for 5:49 p.m. Central Time and would be an 8-second burn using the reaction control system thrusters. We've also been getting some imagery down from Orion, taken by the crew after the trans-lunar injection burn. This photo showing the beautiful Earth outside the window of the spacecraft as the crew was flying away. And this next photo, a backlit Earth as the crew was departing from trans-lunar injection. And if you look very, very closely up to the top of your screen, you can see the aurora borealis, and on the left in those clouds, a couple of lightning strikes. The crew continuing to get beautiful views from Orion, and we're even getting some views from the spacecraft as well. This is a live view from Orion and a camera on the tip of one of its solar arrays looking back at home sweet home and all of us on planet Earth. We are 1 day, 18 hours, and 47 minutes into the Artemis II mission. That's mission elapsed time, or MET.
Yeah, I have the live stream up on two computers, and one of them, they buffer differently. It would actually been, I may try and get a little bit more adventurous with the wake up calls over the next couple of days, and try and have one of them a little bit, or maybe be slightly behind the live stuff so I can mute the wake up call.
And don't forget, as we're showing you those beautiful new images, we really look forward to getting some new ones down periodically. You can follow at NASA and at NASA Artemis on X, Facebook, and Instagram as we all enjoy the imagery taken by the crew and coming down for all of us on Earth. The crew woke up at 12 p.m. Central Time today when they were flying approximately 99,848 miles from Earth, approximately 161,698 miles from the Moon. You probably heard their wake-up song. That was In a Daydream by Freddie Jones Band. The crew is currently in their post-sleep time of the day. This is the time that they use to stow their sleeping bags as well as perform any hygiene activities, set up the cabin for their waking time, also gives them a chance to eat some breakfast. There are a lot of food options aboard for the crew. Of course, a very popular food item are tortillas. There are 58 in total on Orion. Some of the other breakfast items that the crew is enjoying today include vegetable quiche, scrambled eggs, couscous with nuts, peaches. They, of course, have their coffee, oatmeal, there's even a muffin being enjoyed today. During the post-sleep time frame, we don't expect to hear from the crew very much as they are taking their time to wake up, get the cabin set up for all of their events today. Aside from the outbound trajectory correction burn, the crew does have a little bit of off time scheduled. Of course, they are still on tap to be exercising 30 minutes a day using that flywheel device. This allows them to practice aerobic and resistive exercises and keep their bone and muscles strong while they are on the flight around the moon. There's additionally a CPR demonstration today. The crew will use the medical emergency procedures to simulate methods of how to treat an airway obstruction as if they were in space. This is a test flight, so we're taking every opportunity to test anything possible while the crew is on their 10-day mission. They also have some time scheduled today for lunar flyby cabin configuration. Now, we're not expecting lunar flyby until flight day 6. However, they will need to configure the cabin properly to allow them to most easily access the windows and conduct their observation opportunities. This cabin configuration will include getting out any sleeping bags or window shades to keep the light from reflecting from the cabin onto the windows that they're using to photograph. They'll practice handing off the camera between their flyby pairs and determine their ideal setup and positioning preferences for each crew member during those flyby operations. We also have a Deep Space Network Emergency Communications Development Flight Test Objective timeline for today. As we've discussed, the crew is able to communicate through the Deep Space Network, or DSN. This is the first crew in over 50 years to be using the Deep Space Network to communicate back to Earth. They were on TDRS, or Tracking Data Relay Satellite Systems, for a brief time yesterday afternoon as they were near our home planet, but the farther they get away, the more reliant we are on the Deep Space Network. This Emergency Communications Development Flight Test Objective, or DFTO, has the crew perform a checkout of the emergency communications system while connected to the Deep Space Network. Of course, there will not be an active emergency for the communication system at that time. This is giving us an opportunity to check out that system. The crew is also slated to conduct some National Geographic filming today. National Geographic was selected through a competitive selection process to help tell the story of Artemis II. The crew has a shot list provided by National Geographic, and they take some time each day to document what it's like to live and work on Orion. Later today, we also have 2 crew members timelined to activate and check out some of the medical diagnostic devices that we are flying on Orion. That includes the blood pressure monitor, thermometer, stethoscope, and otoscope.
I'm kind of waiting here for Lee to finish explaining kind of the day's activities. It's a really good overview of what they're going to be doing today. Yeah, Woody, I'm seeing seeing a lot of that commentary. We've seen some of it here, see it in the comments. So see some of it in the chat, some of it in the comments, and I'm sure, as you say, it's they go everywhere they can go. I think it's just going to. There's no way to avoid it now. So it didn't get out of hand yesterday. I think folks understand that, you know, the if you push somebody on their belief, you push somebody on their beliefs, they're not going to, it's just gonna, people are set in their beliefs, and so, that's fine. It's more of, where do you draw the line between your beliefs and advocating for your beliefs, and then there's all sorts of different styles to that. So, and so I'm just going to try to, I'll make judgments about when it gets, if it gets out of hand, but it is as Red's saying here, everybody's got to kind of filter what they take in from different sources of information. So I think I'm going to try to, I'll adjust the filters here as necessary. I do think, this is the only time during the missions I think this is something that I'm discovering. I was wondering how much interest there would be during the mission, and it does seem like there's probably an order or a couple of orders of magnitude more interest in what's going on in real time. And so that's neat, but it's going to bring, I guess it's interesting because it does bring that interest from from folks that are skeptical about all of this too. So I think, you know, I think it's just when it gets to be too much of a distraction or goes off on too much of a tangent, and I have to be careful since I'm real good at going off on tangents myself, but I'm also hoping that they're, even if they are tangential, they're still relevant to what's going on. So, you know, now that we're in flight day 3, and this is going to be, as you know, as Lee was talking about and sort of providing the overview of the flight day, there's still a lot of they're taking the time that they have here as they're in transit from the Earth to the Moon before they get there into that work intensive day when they get to lunar flyby day. They're doing a lot of flight test objectives and development flight test objectives, but it's, I guess, in terms of the big news, you know, flight day 1, there was obviously a lot of work in a little bit of time, and then flight day 2 is leaving the Earth for the first time since 1972, and so there's maybe a little bit of this is a little bit more of a focus on engineering, and I don't know that we're going to necessarily see, you know, some of these things. Like we will probably hear some voice checks of the emergency communication system. They did do just an initial check since they were on the Deep Space Network on flight day 1 after the SLS in-space second stage, the interim cryogenic propulsion stage, the ICPS, did the apogee raise burn, and they basically ascended out to an altitude beyond where they wouldn't be able to communicate through, for instance, the TDRS satellite system. So, but there will be, you know, this morning I went through a couple of the launch replays. I mean, it's just, and one of them was just particularly interesting because it was something that we didn't see in totality for Artemis 1, and I think part of that is because it was a daylight launch, and you know, and that's actually an interesting point because, you know, because I'm so focused on this mission, there are other things going on in the world too. So I, you know, totally understand. I was talking to somebody at home, and they're more focused on other world events going on right now too. So, but there will hopefully be a little bit of time here to. I'm going to try and pull some of the pictures, and I probably won't be able to pull a video quite as easily, but I took some still images in the observation room, and let me see. Let me see if I can bring it up on in OBS, which is the broadcast software. Okay, that didn't work. Try again. So you may hear Windows noises. That was actually, so Kevin's asking about laser comms. I actually, you know what? Thank you for mentioning that, because I think that I was thinking of questions.
This is Artemis Mission Control. Now, 1 day, 19 hours, 3 minutes mission elapsed time. You're looking at a live view from the Orion spacecraft back at all of us on Earth. This camera is mounted on one of Orion's 4 solar array wings. These are some of the same cameras that we'll be using when we fly by the moon on flight day 6 to give us views of the lunar surface. Now that we're at the start of another flight day, our crew is in their post-sleep period. Let's get a look at who is flying aboard Orion. Artemis II Commander Reed Wiseman is a Baltimore native who has flown in space previously as a flight engineer for Expedition 41 aboard the International Space Station. That was from May through November 2014, a total 165-day mission during which he and his crewmates completed over 300 science experiments. They also set a milestone for station science by completing a record 82 research hours in a single week. Wiseman also served as chief of NASA's astronaut office from December 2020 to November 22, and back here on Earth has 2 daughters. Pilot of Artemis II is NASA's Victor Glover, selected as an astronaut in 2013. At the time, he was serving as a legislative fellow in the United States Senate, and his first trip to space was in November 2020 when he launched as the pilot of NASA's SpaceX Crew 1 mission. Victor is a U.S. Navy captain and naval aviator who served as a test pilot, racking up more than 3,500 hours in more than 40 different aircraft, and he and his wife have 4 children. Mission Specialist Christina Cook is a native of Grand Rapids, Michigan, selected the same class as Victor Glover in 2013 to join the astronaut corps. She served as a flight engineer on the space station from March 2019 to February 2020, during which she set a record for the longest single space flight by a woman, totaling at 328 consecutive days in space. She also participated in the first ever all-female spacewalk, and before becoming an astronaut, she helped build space science instruments and led scientific field work. Her hobbies include surfing, rock climbing, community service, yoga, travel, and photography. And she is certainly getting a chance to practice that photography on this mission. First-time flyer and Canadian Space Agency astronaut Jeremy Hansen is flying to the moon as a mission specialist on the Artemis II mission. The London, Ontario native was selected as an astronaut in 2009 and since then has worked as a Capcom at NASA's Mission Control Center here in Houston. Capcom stands for Capsule Communicator. That's the single voice you hear communicating with the astronauts in space. He also participated in training exercises like living on the ocean floor off the coast of Florida for 7 days, all to simulate deep space exploration. And in 2017, he became the first Canadian to lead a NASA astronaut class. Jeremy and his wife have 3 children. That's who's flying aboard Orion. Again, this camera coming from the spacecraft. On the left side of your screen, you can see the European service module, just the bottom portion of that, and the OMS engine, the Orbital Maneuvering System engine. That engine alone provides 6,000 pounds of thrust, and that's what we used yesterday during the 5-minute and 50-second burn, the trans-lunar injection burn that committed the astronauts to their lunar trajectory. They will fly around the moon on Flight Day 6 and splash down in the Pacific Ocean on Flight Day 10. That OMS burn is not intended to be used again. For all of these orbital trajectory correction burns, again, targeting the first one of those today at 5:49 p.m. Central Time, exactly 23 hours after the trans-lunar injection burn, the spacecraft will use the reaction control system thrusters. These allow for much smaller, finer maneuvers, and that will only be an 8-second burn, helping the crew maintain their trajectory around the moon.
This has a nasty... Okay, is that okay? I guess it's okay. This has kind of a nasty behavior to get out of sync or to click the wrong... when I didn't... It's transferring clicks from one window to another. So I saw that question from user 80,011 It is. That's a good question. So, if you're referring to those two stills that they showed in the broadcast at the top of the orbit one signing on, I guess. Yeah. Let me. The place I go just in general is images.nasa.gov, but Public Affairs did advertise, so to speak, a couple of, yeah, they're there. So here, actually, let me see if I can do this. So, I think we can do this for the time being, especially when they're in the middle of Arrow. Okay. So this is there are other places. Let me see if is this the, okay. So for instance, like this, they're showing, so so I have to go grab some of these things, but this video here, this video looks like it's the video shot from the Orion crew module adapter looking down at the stack, so you can see it's on the, actually it looks like you can see the one of the lightning tower bases there. But anyway, if you actually, a lot of times you want to let it load,
a live view of Orion,
and then click the newest uploads again. So there's that still.
That helps track where the spacecraft is. This is called Arrow, Artemis Real-Time Orbit website, and you can visit this anytime for yourself at nasa.gov/trackartemis. As you can see, the spacecraft is now over 100,000 miles from our home planet and inching closer to the moon, 159,728 miles away.
I'm going to come back over here, or try to, but actually it looks like there's quite a bit of stuff. So this looks like an image that the crew took as well. And if you, I don't know if you can see down in the, let me see if it shows up. It may not show up, but it's showing the link in the lower right on, I think it's captured there, but you see, if you see the number there, again, the lower right, you see the URL, the link, and it says /ART002, and then I don't know if that means electronic image, but those, if you see files that have that nomenclature, and apologies for using that, but those are typically images that are taken by the crew. So you see that's 191, and then this is 192. This is a Soyuz picture. That's not Artemis II, but so this is, okay. It says it's taken by Reed Weissman as well. So, so these I called these landing pages because you come to this page and then you can click on download, and you can download if you want. You know, again, if you had a live stream, for instance, I don't know why I would say that, but you might be going for a thumbnail sized image of this. But if you want to look at the full res, you just click on the original one, and I'll go look for the other one. Actually, you can see the aurora. You can see the aurora up here as well. And again, this is not exactly like there's a very famous Apollo 17 image because it's a full disk image. I think you may be able to see, I don't know if you call that the atmosphere or not. Is this the nighttime view? Because it looks like, no, those are city lights. So, but anyway, it's a really interesting image. I'm not sure what strait that is. Is that the Strait of It's not the Strait of Gibraltar or not. But anyway, those images are there, and then again, I'll have to go find the. Although I guess what I would suggest is that? Yes, so that's a black and white image. What I would suggest is kind of coming over here. This is something I do all the time. I'll come over here and look around. Is this okay? That's that switched feed of the onboard SLS core stage camera views, and then of course we're getting more and more imagery from the launch. Some of these are older, but there will be some that won't be. Let me see if so let me go back to the. If you go back to the landing page, there are some keywords here. I'm going to see if the trans-lunar injection one. Yeah, so that's an interesting shot too. So, Terminator line. That's interesting. So that one. So this is much older, but that's okay. So you could. So if you wanted to filter down, you could change this to this year. Not as many missions. Not a lot of real TLI missions for the last several years. So if you isolate it to just 2026, you'll get that. So then this is the let's see, what's the number? So this is 193. Obviously the numbering, if now that we look at this, and there this about half lit. So these images were taken. You might be able to see the metadata, the EXIF data. That'll give you date time. I mean that's the numbering. They are not. The crew is not numbering these images, and so, but you can see they're kind of all over the place on a timeline. But if we take a look at this, so these are numbered in sort of a contiguous fashion. Is that the moon? No. It's one of those stars, apparently. Like this. I think some more stars. Don't tell anybody. But I think I thought I saw one of those constellation thingies. But anyway, you can, if you go to images.nasa.gov, you can, if you find one of these images, then you can use, let me go back to the, you can use the keywords to sort of narrow down on, so you could use Artemis II, for instance, but the problem is there are hundreds of pictures of Artemis II from, training 3 years ago all the way up until today. So anyway, but this is also a pretty stunning picture as well, but still the same thing of city lights. But I think, yeah, so that would be lightning. These lighted areas, some more lightning over here. And then I think this is probably a mixture of, well, this might be more city lights and a mixture of city lights and lightning.
This is Artemis Mission Control at Johnson Space Center in Houston, Texas. Again, on your screen, getting a live view from Orion, looking back at all of us here on Earth now. 1 day, 19 hours, coming up on 18 minutes into the Artemis II mission. In about 45 minutes, actually just a little less than an hour, the crew will have their daily planning conference where we hear them discuss the day with the flight control team here on the ground. Additionally, some of the team members or the crew members will take their pulse ox using the pulse oximeter measurement. And some of the crew members will even get to conduct their private family conferences. The crew has not gotten to speak with their families directly just yet, and so this will be the first time during the mission that they'll be able to call down with video and speak to their friends and family. Of course, as those conferences are private, we won't be able to air those, but we are excited for the crew.
just kind of going back, pardon me, I'm still going through some of the launch footage. I probably won't really be able to go through it all until I get back home. And I tried to bring enough computer equipment here, but pardon me, it doesn't seem like it's good enough, but it'll be easier to sort of to do a lot of this at home and multitask a little. I can multitask a little bit better at home, really just because I can start something on one computer and let it go autonomously. But I've seen some of the footage, so I did see I was talking about the switched feed, and that just means again that during launch the SLS core stage has it has an avionics box that's tied into the flight software and flight computers, and obviously the communication system as well. It's called the camera control unit, and there are cameras on the exterior of the stage that are looking from the top essentially down towards the aft end of the vehicle, and vice versa. From there, there are 4 cameras that are mounted around the circumference of the engine section, looking up. And during launch, again, I'm sort of euphemizing, but SLS basically only has one live downlink stream, so one live stream of video that it can broadcast to the ground in real time, and so they can only pick one of those cameras at a time to take one of those cameras at a time. And so I believe that recording that was published is essentially that feed, that recording of that live stream. And then later, after main engine cutoff, all of those cameras, kind of like what we have here with Orion. So this video is being recorded on Orion to local hardware in full high definition, whatever the maximum resolution is. Or of course you can also configure cameras to, you can configure a camera to record in 4K or 4K 30 or HD 1080p 60, that kind of thing. But at any rate, it'll record whatever the cameras, however the cameras are configured. But we can't necessarily get that down because the spacecraft is so far away from the receiving stations, and so the bandwidth, there just is no, there are no cell towers between the spacecraft and the planet, so they have to use a different type of communications, which is lower bandwidth, but there are other considerations in it beyond just bandwidth. But at any rate, in terms of the launch, you have the live stream, the single live stream, and they switch the cameras. Then after main engine cutoff, there's a short window of time, a handful of minutes, where the core stage is still within the line of sight of that downrange tracking station. It's actually downrange tracking and ground communications station in Bermuda, and the stage will attempt to download, push those recorded files down to the ground before it goes over the hill, basically. And so hopefully we also got those, but it may take a little while for them to be published. And we did see a few breaks in that video of 10-15 seconds, and it's not clear whether that was a dropout or if those were cut out for things like export control. But hopefully we will see each camera, the full recording from each camera at some point in the future. And so that was the one launch replay that I was, out of the ones that I saw, that was the most interesting, just because it's on board, and I'd already seen quite a few of the launch replays during the NSF NASA spaceflight coverage. I would like to see all of them again and full res, or pardon me, at least the full res that can be published. So it may take a little while for all of that to be published. Actually, and I keep forgetting. So again, somebody was asking about the optical / laser communication. That is a good question, because just in terms of not just evaluating it, but also when are they going to use it, or
this
if they're
Artemis
already using it, how are they going to use it?
We are now exactly 3 days and 5 hours until the beginning of lunar flyby. Of course, the view on your screen from Orion looking back on Earth. Mission elapsed time of 1 day and 19 hours, 27 minutes.
I think I have, folks are mentioning some of the things that are going on in the broader world. Even within the industry, it's like I am staying. I think the two things that I'm keeping my eyes out for, obviously this Artemis II, but then also keeping an eye out for some of the preparations that are already beginning for Artemis III. But I don't know how much it is. When I went to the Space Center this morning, I'm like, wow, the traffic is really light this morning. And then somebody said, yeah, it's a Good Friday. So it's like, oh yeah, it's possible that the schools are all out here. And of course, Easter is on Sunday. So, but I kind of slipped my mind. But I did see when I woke up this morning, I took a quick look at the phone, so to speak, and I believe Mr. Musk is advertising the first version 3 Starship launch in 4 to 6. Was it 4 to 6 weeks or 6 to 8 weeks? I think it was 4 to 6 weeks. So I could be wrong. It was one of those two. So it's soon, but not next week apparently. So
here in Mission Control Houston, and specifically the Artemis Flight Control Room, Jeff Radigan is the lead flight director for the Orbit 1 shift, which is on console right now. Every flight controller monitors a different system aboard Orion, and they are beginning to prepare for the daily planning conference that they will hold with the crew.
I guess I can try and bring up the summary timeline.
We're expecting that daily planning conference to come up in about 40 minutes. During that time, teams on the ground will report the status of the vehicle and any activities the crew needs to be aware of as they move throughout their day.
Because it is useful for the public affairs officer in the flight control room. In this case, Lee, she can elaborate on some of these things. So she's talking about the daily planning conference, and so I will try and bring that up on the pardon me, on the screen here. I need to adjust it a little bit. So I'm trying to leave the flight day 3 thing up there, even though we're out here approximately. Well, that's not actually. She just said they're a little ways away from. Oops, that's not what I wanted to do again. We're a little ways away from that when that daily planning conference occurs, but that's what this is indicating. And then the pulse ox thing that you guys were talking about. I'm spacing on the PFC, but she did talk about this. So again, if you recall, she was essentially previewing flight day 3 at the top. So it is possible, JC, that let me scroll down to the bottom of the screen. So this was based on the April 1st launch, but you can see again this document was released more than a couple of weeks ago now, but approximately 2.5 weeks ago. So this was what they were. I should probably go look and see. And that actually is another reminder. I can do that over here, I think. But NASA is also releasing a TV schedule, an updated TV schedule. It's as a spreadsheet format. That's useful because they will have updated times for things like, crew wake up and so these might be off a little bit. Let me make sure that I'm more or less live. I'll go ahead and catch up with the live stream and the commentary. So I'll go. Let me go and I'll show you. I took a selfie in the observation room. That's a little bit blown up. All right, so I need to adjust this ever so slightly. I'm not sure why it is why it's that large. And so I'm going to go kind of every time I get a shot to every time the public affairs commentator comes up, gives me an opportunity to in the background try and find some pictures to show you from earlier today. So I think trying to think what was I showing before that would probably be more useful. I can just go back to the at some point I'm gonna have to go back to the I will go back to the live view, but that was from, let's see, that was the 9 o'clock Central hour here in Houston. That was probably the least interesting image. So what I want to try and do here is so that question about the optical communication system, it's like there was an indication on one of the displays in the flight control room that system was operational, or at least that was my impression, and so that's why I wanted to ask about it. I don't know, it's not, or somebody to ask about it, but for things like downloading imagery, they have the standard way of downloading these images, and so what the laser communication system would give them is the ability to not have to be as selective. They can hopefully pull down high def video. It's just that it's the way that it sounded. The timing wasn't going to work out for them to be able to live stream that, live stream in high def. And so the idea would be to, download pictures kind of like we would download off the NASA site and replay them later. Yeah, they have the ability to download specific image. Well, yeah, I mean to download files from the spacecraft through the standard communications channels, and the overnight shift while the crew is sleeping is a good time to do that because there's less critical operations going on, and so you can afford to take up a little bit more of the overall data bandwidth between the spacecraft and the ground. So they have in the timelines, they have these windows. Is it the blue bar? Yeah. So you see there the OpCom in blue, and you can see the windows are typically during their overnight hours. Let's see. So how do you get that one? And it's actually possible that they. I think if you search on this, let's try it for grins. If you search for Artemis II overview timeline, you might get it. I mean, I can try that in the browser here. Whoops. Was I supposed to? Yeah, okay. This does say public final. I don't know if this is, let's see if this has a, does it still, no, okay, that's interesting. There is, I think this is, there was another link. I don't know why that's the January 8th one. I don't know why. Oh, okay. You know where it was? It was, I think it was media resources. So yeah, that's a little bit of an inconsistency there. There's a link. I believe this is where I found this. So there's a link to mission resources. So if you go to, Artemis II media resources, and then if you scroll down, there's a link to, so Artemis II overview timeline for April 1st launch. It's at least a more recent rev. And then there should be, there is supposed to be a link on within just the regular nasa.gov, like here, the Artemis II multimedia. I think this is what they were advertising. So, again, there's that link. So, nasa.gov/Artemis-II-multimedia. I'm sure that those pictures of considering they just posted those, I would imagine, yes. So if you go to mission images, but as we saw, you can also find them on images.nasa.gov. Pardon me. I think this image may be essentially a frame from the downlink during the PAO events last night. But I suppose we could try and ask them. I would imagine that these timings, the March 18th timings, they're at least reasonably close to. Okay, now we're flight day 3. Somebody, I don't know if they're here today, but I think at the end of one of the live streams, and they kind of blur together now, but somebody posted what the DU acronym means in this context, because we heard them.
You're looking live at a view from Orion on the Artemis II mission, now over 104,000 miles away from Earth, 158,440 miles away from the moon. We are 1 day, 19 hours, and 42 minutes into this first flight, a test flight with the crew. And you're getting a view right now from a camera on the tip of the solar array wing, one of 4 solar array wings aboard the spacecraft. These cameras allow us to take surveys of the exterior of the spacecraft, but they also give us views like this. You are looking at a live image of the moon. Again, the spacecraft now 158,420 miles away.
Can you, Conan, what was because we heard them talking about, the displays are called display units, DUs. So, I think Christina, I believe yesterday, during, it was either before or after the TLI burn, Christina said, DU number 2 had freaked out, and it's like they said, they basically said, just power cycle it. And I believe that essentially brought it back up. What does DU mean in this context? Because I believe I don't think it was display unit. I don't know why they would have a block of, I don't think they would have a block of time for that. It means something else in that context.
This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. And as we enjoy this view from outside of Orion looking toward the moon, inside Orion, our 4 crew members are still in their post-sleep period. Again, they woke up at 12 p.m. Central Time today, and since then have been configuring their cabin for the day's activities, as well as conducting hygiene and preparing for the rest of their day. We won't hear from them for probably another 30 minutes when we conduct the daily planning conference. Here on the Orbit 1 shift, the flight director, Jeff Radigan, gathered inputs from all of the flight controllers on the systems aboard Orion and anything that they needed to ask or share with the crew for today.
Maybe she'll mention... Okay, no. No, that's probably not it. Maybe she'll mention it when we get closer to that in the timeline. maybe it is, well, maybe it is in the blog post. Yeah, I don't see it in the blog post, and so somebody in chat is. No, that was not a good idea. But somebody in chat was answering the question about what is a lunar flyby. So if just to add what chat is saying there, so for a lunar landing mission, we would see the same types of burns, except they would have combined the apogee rays burn and the TLI burn that were done by separate vehicles into one burn. So, SLS launches the core stage and the boosters, insert Orion into an orbit. They circularize. That's probably not a good way to euphemize that, but they raise the perigee up so that's in a safe orbit, and meanwhile the core stage re-enters and is disposed of. Then they do the TLI burn that takes them to the moon, and if they did nothing, which is basically what's happening on Artemis II, they would loop around the moon, and they would use the moon's gravity to slingshot them back to Earth. And that's what's going to happen on this mission. On a lunar landing mission, the next step, if you weren't going to just do a lunar flyby, would be to go into orbit around the moon. And so you would do, as we see with planetary spacecraft, if they're going to Mars or they're going to Jupiter, there's an orbit insertion burn that they make when they get to the moon or to Mars or to Jupiter, Saturn. So instead of just slingshotting around the moon, if you wanted to go into orbit, you would make a lunar orbit insertion burn. Or in the case of Artemis I, which went into an orbit around the moon, they do a series of burns that get them into these more complicated orbits of the moon. It starts to get pretty complicated. So let me see if no, they're still showing the. Let me see if I can bring up the. No, that's not it. I have to be careful about the. Actually, I do have to be careful about the time again. What I'm planning on doing, and hoping that there aren't any more copyrighted music. There isn't any more copyrighted music played on the NASA's live stream. Is I'll probably leave this up to go back over to the Space Center and for the news conference / mission status briefing. But so the TLI burn gets you a lunar flyby if you do nothing else. Then you go in. Then if you make a lunar orbit insertion burn, then you go into orbit around the moon. Then, if you want to, you can lower your orbit down to approximately, was it 10 miles altitude? Something like that. So again, I'm going back to Apollo. Then you can do a powered descent initiation burn to actually go all the way down to the surface. And then to return, you do sort of the reverse. There's a liftoff. There's a lunar ascent back into low lunar orbit. And then you do, if you need to rendezvous at another place, then you'd have to transfer to some of these other more complicated orbits. But now we're back to this. We're back to a. We're back to something besides the near rectilinear halo orbit.
Stowage question.
Good morning, Integrity. We're ready to take your question.
Good afternoon to you, Chris. I think it's afternoon there. We were wondering if we could get some help finding the electric shaver.
That's right, Christina. I think we're in afternoon here in Houston time. I'm keeping Orion time myself. And we will get a location for you to look here shortly.
Thank you. Asking for a friend.
This is Artemis Mission Control in Houston, Texas. Some of our first calls from the day coming down from the crew. Since they have woken up, they're still in their post-sleep period. Again, they're able to conduct hygiene tasks at this time. And so that was NASA astronaut and mission specialist Christina Cook calling down to ask about the location of the electric shaver. Now, all of the items that are in Orion are carefully tracked and stowed, so that way when a crew member calls down looking for any piece of equipment, flight controllers here can look up exactly where they are able to locate it within the spacecraft. So while teams on the ground are checking, they will be searching their systems and relay back up to the crew a very specific location that they can expect to find that shaver.
Yeah, I'm not sure what PPC, so PFC, I assume, and again, so this timeline has been modified, but I believe PFC stands for Private Family Conference, PMC Private Medical Conference. So I'm not sure what PPC stands for. And so the FD conference is the one with the flight director, and that's more of a that's like a phone call to your manager where you're talking about your workday. I'll see if I can. And so DPC, daily planning, I guess it could be private planning conference. So DPC is daily planning conference. Maybe it is, maybe it's. I'm not sure why they would need to have a private planning conference on only one day versus periodically. I mean, I guess it's not out of the question. But then, as she was mentioning in the commentary, the crew's going to get a chance to talk to their families. And so that would be pretty soon if that is indicated here as the PFC. And so the toilet, the toilet noise is fairly self-explanatory. They are trying to record the sound levels. So the Orion probably sounds like if you went into a server room. Of course, in the server room, the air conditioning and those fans are going pretty loud themselves, but I think they're, they have health rules, I think, in terms of the level of background noise. And if it gets too high, then you put in something to protect your hearing, or at least you would want to have the ability to do that. And so they're trying to characterize how loud's the toilet when you flush it, basically. At least, again, that's my understanding of it anyway. And there were a couple of other, there was another, so there's an acoustic, here on flight day 4, there's an acoustic, testing the acoustics and characterizing, again, how loud is it basically inside Orion under different, I think that one's more of, I don't know about passive, but it's, rather than, they would not be trying to turn everything on because that has its own side effects. But they're just going to, I guess, record the sound during a 24-hour period to try and try and characterize that. I was gonna go. Was it track Artemis? I was gonna go. Well, let me go back. Let me make sure. Okay, no, it's not there. So they've got the live view, assuming I'm still live. Yes, or relatively live. But yeah, I need to remember. Because yeah, in about 20 minutes, I'm going to need to get ready to go over to the news conference. Although again, it's been a very, they have had some issues, but they've been relatively minor. Obviously, no showstoppers for making the burn to go to the moon, but they did have some issues. And I think again, the question about the false alarm that they had about the cabin pressure yesterday before maybe a half hour before the burn, and that just, again, they were talking about that last night in the news conference, and it's just this is the first time that they're running all of these systems because it's the crewed demo, it's the first crewed Orion flight, and so they're learning how to live in Orion, and so as they change the configuration of some of the fans in the crew module, that caused the pressure to dip below one of their set points, and that just triggered an alarm. I guess it's not a pressure alarm, but it's like, if you
Integrity, Houston, with a possible razor location.
If you're cooking something and the fire alarm goes off, it's kind of like that. I mean, it's not always, again, so sometimes when the fire alarm goes off.
Good morning, Chris. We are ready. Go ahead.
Good morning, Christina's friend. You may look for the razor in locker D, bag 6. We'll have a purple label. This is Reed's suitcase, and we expect it to be located in the crew hygiene kit.
Okay, we copy that. Thank you, Locker D Bag 6, and we will find you. Appreciate the help.
This is Artemis Mission Control. That call from Capcom and NASA astronaut Chris Birch being received by NASA astronaut and pilot of the Artemis II mission, Victor Glover. If you recall, recently NASA's Christina Cook called down to inquire about where the crew might find an electric razor. And if you listened closely, you heard the team on the ground is able to provide the exact location and locker where that would be stowed.
Oh boy. I think I've gotten out of sync again with live.
Good morning. Yes, absolutely. We would love that.
I think I may have skipped over something there. No, well, I'm not sure what was. I believe that the laser communication system is
in the next 10 minutes. We will
working.
have the daily planning conference where teams on the ground will relay any details astronauts need to know about the Orion spacecraft ahead of their flight day 3.
So she's a little
from
rushed
looking
here
toward the moon.
But
at this time, Orion is 157,560 miles away from the moon. And during the daily planning conference, we are looking forward to potentially seeing the crew living and working aboard the spacecraft.
Okay. That's nice. I'm still going to have to go in about 15 minutes. So, but again, like I said at the top, somewhere around the top, I'm going to plan on leaving this live stream up. Maybe what I'll do is I can take that one down because it's a little bit more intrusive. But so yeah, I'll be gone for a little while. But this news conference is at a little bit more of a earlier in the day. Okay, so here you go. And so that's another reason why I took that little graphic or watermark down, is just because that's where they stick those numbers. Thanks to Sleeping Bee 5748 for becoming a member of the channel. So, you know what? Let me see if I have time to pull up at least one picture from one of the stills that I got that was not of me. One of the interesting pictures rather than the one. We have a couple of minutes here, 21, so I'll do that one. Let's see. That's okay, just from a
Integrity crew,
Hello,
we are now on board.
Here at the
Great to
NASA
see you
Johnson
guys.
Space Center. How do you hear me? Fantastic. Yes, this is the main
Copy those
feed and
thumbs.
only
Great
feed
to
that
see
will
you
be
guys.
providing
Good
audio
morning.
to the conference. We usually do, but today we're in live mission coverage. So if you have music that you would like to play, that might be a good thing today.
Uh-oh. That will not be good for me. Let me see if I can, while we're waiting. Well, too late. Not going to worry about Well,
You're getting a live look inside the Orion capsule at our 4 Artemis II crew members, now 106,000 miles away from Earth. We are standing by for their daily planning conference, where teams on the ground will be relaying up information for the crew as they start flight day 3. From left to right, we have NASA astronaut Christina Cook, Reed Wiseman, Victor Glover, and on the far right, Canadian Space Agency astronaut Jeremy Hansen.
Well, I guess I'm going to have to hope that it's not. So here again, this is just behind the curtain stuff. So yesterday I left that one stream up the whole for about 10 hours, and I actually it captured both of the wake up music, playing of the wake up music for both that ended both of the naps. Well, that music's copyrighted, and so YouTube basically demonetized the stream, and it blocked it in a few countries
inside Orion,
because of that.
The interior habitable volume is 330 cubic feet, so that's about the size of 2 minivans. This is 60% more cubic volume than the astronauts had during the Apollo missions.
The spacecraft structure.
Integrity, small request. If you could tilt the camera down slightly towards the lockers. We have a great view of Christina and some of the boxes up above.
It's not.
No problem, Chris. I did not mount it. I just kind of friction fit it, and I'll get a better spot for it later today, and we'll get a more permanent mount going.
Sounds like a great plan. Thanks.
This is interesting because you can see. I think you see it last night too, but you can see where they're stowing their launch and entry suits right now. At least a couple of them. The spacecraft structure. The structure, there's more of the structure there to sort of at least get in the way of the radiation. So they don't. If they were to have a significant event, then yes, they'd have to build the shelter, which they're going to do as a test objective anyway. I think it's on. Is it on flight day 7 or flight day 8? It's after they're on their way home, but. Yeah, they do not. This does not have. If they had a significant event, then they would reconfigure the cabin, get in the middle of the, sort of in the middle of the floor, and put things like water and other things like that around them as much as they could. But yeah, as noted, they're not. There's no severe space weather at the moment. But yeah, if
Houston Integrity, we're ready for morning DPC.
Good morning, Integrity. We are so happy to be on board with you today. You guys look great. That cabin config looks amazing. We would love to be on board as much as possible today. We'll stop streaming for the family conferences, but would request to come back on board afterwards to share your mission with the world. I have quite a number of topics for you today. I'll start with trajectory. We are actually going to continue evaluating the need for OTC-1 based on the small magnitude of the burn. We'll have an update for you later. A couple of vehicle statuses. In order to address what we saw last night with the small increase in ox tank pressure accompanied by a small decrease in the ox helium tank pressure, we did to do some troubleshooting. We closed the valve ox helium isol 1. You can see this on the top left of your prop ohms plus X page. We're continuing to look at that. Don't have a full story for you yet.
Okay, I'm not at the displays right now, but I will take a look at that soon.
Great. And then just a reminder for the memorized response for the manifold run box, plus X manifold run box fail message we saw last night. Memorized response would be DAP free first, then secure SM prop.
Yeah, 100%. And I elected not to take that action last night because it was coming in and out of alarm. But if you tell us you want us to take action immediately, let us know.
Copy, Reed, will do. All right, continuing on. We're planning to manage our wastewater tank to a lower quantity. So we'll expect some real-time coordination. Basically, we'll be adding some wastewater dumps that are not captured on the timeline. So we'll let you know when those are going to occur. And then regarding those wastewater dumps, when we perform those or have performed those in the past, do you guys hear any sounds in the cabin? We want to know if we need to deconflict those activities from other activities on your timeline.
No sounds, but it is certainly visible.
Copy that. Thanks. All right, regarding the PWD delayed flow termination, we wanted to let you know that this is actually behavior we've seen on the ground, but we'll still take any data that you gather from the flight. And there are some prompts in the mission summary for that. We can turn to that at the end of this update.
Okay, sounds good. We did figure it was just inherent in the design of the system and the tubing, and it's an efficiency hit and a bit of a cleanliness hit for us, but primarily an efficiency hit.
Copy. Good report. All right, moving on to PCDs. This is just a reminder that PCD 3 will need to be hardlined for the family conference. And then sometime today, at your convenience, we need to power cycle each PCD in turn to clear out any hard drive errors.
Copy that. We'll get on that after DPC.
Great. And then finally, some feedback on science collection. This is the first time you performed saliva collections. Any feedback or concerns you want to pass along?
None that we can't do in debrief after the mission. It was fine.
Okay, copy all. Now we are ready to take any answers you have from the mission summary and answer your questions.
Okay, from the mission summary, question number 1, we are good with PCD 3 for now. Question number 2, we are good with cabin temperature overnight. We might make an adjustment in a day or two, but for now we really appreciate all that help. It's going well. For question number 3, I think we just covered that. It is primary and secondary. For question number 4, we put a lot of thought into that, and we definitely agreed that your method was the best. Ike did a good job putting some towels around the dispenser, and overall, he and Christina had a very good cadence going of doing the fill. So that was about the ideal way to do it. It was not very messy once I got it going. And then for question number 5, we would like to just have Christina call you later when she's got some gray space.
All right, copy out. Good plan.
And one go back on number 3 for the PWD. I think we're all synced up, but that has been since day 1. That didn't just start happening. It's just due to the design of the tubing.
Yep, copy that clarification.
It was really great to wake up this morning and look out the window and see the full moon off the front of the vehicle. There's no doubt where we are heading right now, and really appreciate all the work down there. It was also really awesome. Thank all the FIDOs. I can't believe that actually all worked. And when I saw that OTC-1 was like a 0.8 meter per second burn this morning on targeting, I thought we might skip it, and that is pretty impressive. All right, signing off.
Thanks, and copy all integrity.
This is Artemis Mission Control. That was Capcom Chris Birch here in Houston, Texas. She is also a NASA astronaut, speaking with the crew living and working aboard Orion for the Artemis II mission. We are now 1 day, 20 hours, and 17 minutes mission elapsed time for Artemis II. That was the conclusion of the daily planning conference. However, if you listen to the start of that conference, you did hear the relay to the crew that we hope to have the cameras on as much as possible throughout this flight day to allow us to share their journey with the world. So we intend to be able to share the crew with you as much as we possibly can. They are going to move into some of their other tasks today. Again, you heard them discussing the OTC-1 burn, that's orbital trajectory correction burn, or sorry, outbound trajectory correction burn. And Christina Cook taking the camera to show us a wastewater dump. So you heard Commander Reed Wiseman reporting that they don't necessarily hear those wastewater dumps, but that they do see them. So you're getting a live look outside the windows of the Orion spacecraft as they conduct that wastewater dump.
Integrity, we copy that successful wastewater dump.
All right, I'm gonna have to head over to the Space Center. I guess I'll take my chances and hopefully.
At this time, the Orion spacecraft is over 106,000
hopefully the copyright gods do not frown on anything that is
miles
played
away from the moon. We are.
Speaking of that, that's my cue. So
we are moving along with the crew's day. We intend to see them quite a bit, but we are going to not have views for a very short time, as they are going to be speaking with their families. These are timelined opportunities to speak with family members down on the ground, so we do turn off the cameras for their privacy at that time.
I'll hopefully be back here.
As we were discussing the outbound trajectory correction 1
maybe
burn, it was
hour and a
timelined
half,
for
maybe something
5:49
like
p.m.
that.
Central Time, exactly 23 hours after yesterday's trans-lunar injection burn.
We'll see what they say about the CME.
Integrity, we are all configured for the family conference. You are go to deroute the live stream video, and we'll see you after the conference.
As we mentioned, the crew is getting into their private family conferences, so we are not going to having views inside the cabin at this time, but a pretty good view from one of those solar array wings looking at the moon, again, about 156,800 miles away from the spacecraft. Lunar Flyby Day will be Flight Day 6, and our live continuous coverage will be showing you all the views we possibly can of the lunar surface and the crew as they perform that work. But again, that outbound trajectory correction 1 burn, it is exactly as it sounds. It's to help the crew maintain course for their flight around the moon, and it is a follow-up to the trans-lunar injection burn that occurred yesterday. That would only be an 8-second burn today, so as you heard Capcom Chris Birch call to the crew, it may not even be necessary because our trajectory is so spot on. This is Artemis Mission Control. We are getting live views from the Orion spacecraft looking at the moon, the destination of the 4 astronauts living and working aboard the spacecraft. Again, the crew woke up at about 12 p.m. Central Time today. They entered their post-sleep period, conducted their cabin configurations and hygiene before moving into the daily planning conference, which just wrapped up about 10 minutes ago. We do intend to see great views of the crew throughout the day while working aboard Orion. However, one of the crew members is enjoying a daily family conference right now. So while they are speaking with their family, we do appreciate the opportunity to give them some privacy, and you are getting this great view of the moon, currently 156,440 miles away.
Houston integrity question on grab sample container.
Christina, ready for your question.
Thank you. Do you need me to use a specific serial number or just either?
Either is fine. Thanks for checking.
Copy, thank you.
This is Artemis Mission Control. I am NASA PAO Leah Cheshire, joined here by Canadian Space Agency astronaut, Artemis II backup crew member, and a Capcom, Jenny Givens. Thanks for joining us.
My pleasure. Thanks for having me.
So I would love to know a little bit about your experience as a Canadian Space Agency astronaut. What has that journey been like for you?
It has been overwhelmingly positive. I mean, I feel very lucky to be in the role that I'm in, but it's just really the honor of my life to work missions like this. Like seeing one of my very dear Canadian colleagues and my other dear friends in space has been pretty phenomenal. So the past few days have been exceptional, but also just to be embedded here at NASA as a Canadian astronaut. We have an excellent partnership and we're boots on the ground here at NASA. And I see every day really the results of what you get when you have a shared mission and you work together, and we just have a really bright future. I feel very positive about being here.
I agree. It's very exciting. So you've been training as an Artemis II backup crew member alongside the crew very closely. Can you tell us what that's been like?
Yeah, absolutely. It's been a long road. So backup crew members, we're kind of in an interesting spot because we do all of the crew training, and it's a very developmental mission. It's very nascent, so we're still learning. We do a lot of developmental work and contribution. Right there alongside with the crew, there were 6 of us assigned to this mission, and 4 of us are up there now. So that's a joy to see. And as we approach the mission, my work really transitioned to support. So what can I do to get these guys safely off the ground? Andre and I both worked as astronaut support people. You saw Dre strap our crew into the capsule, which was very cool. And now I have the pleasure of sitting the Capcom console. So supporting them with my training and knowing what they know. And I have a lot of joy every day I see them up there. So it's been great.
Fantastic. And you mentioned the Capcom console, so you are going to be our Capcom, our capsule communicator during lunar flyby. Aside from participating in sims, the simulations alongside where the crew is in the simulator, we're here in Mission Control Houston. How else have you been preparing for that monumental day?
I have had the pleasure of working very, very closely with our science console. So for Flyby, we'll have Kelsey Young in there. She is a phenomenal geologist, along with many of other science support people. And they really have been training us about how to observe the moon in a way that's accurate and helpful, but also just beautiful. Like imagine what these crew are going to see. I just can't wait for that shift, like talking to them as they approach the flyby, fly so far away from our Earth, look back and observe both the moon and observe our own Earth. It's just an honor to share that milestone with them. So a lot of crew training, a lot of work with the geologists, which also has been a joy, and my own preparations about how I just want to share this with the world. I want people to be really proud when they see our crew do this and see themselves in the words that they share.
We are so excited. I am counting down the hours. In fact, we are 3 days, 3 hours, and 49 minutes into the beginning of lunar flyby. And so talking about your Capcom experience, you were the lead Capcom for Expedition 63 aboard the International Space Station. So how did that help prepare you for this, and what are some similarities and differences?
Absolutely. Well, flying the ISS is obviously, you have a lot of the same roles here in Mission Control, but it's very different. This is a very small ship. We have our crew totally plugged into what's happening all the time, a very defined mission and a much shorter mission. So I would say it's much busier. But our ISS training has really equipped us well. So like the relationships that I formed on that increment, I am seeing a lot of those flight controllers in the room with me for TLI. We had the same INCO or like comms controller here, that was a joy. So really relying on the relationships that I formed earlier, that's just paid dividends and has been so positive to see those people shine in their roles. And then you just learn how to talk to your friends in space. And what a cool thing. What a cool thing we get to do. So really, we laid the groundwork in a lot of our ISS work for this mission.
Yeah, truly an honor. And so before we wrap up, I know you do need to get back to the Capcom console. Do you have any parting words? Anyone you'd like to give a shout out to here?
Yeah, absolutely. I have to give a shout out to the families. So seeing the resilience that the families of this crew and my own family have shown as we work to go further than we've ever gone before. You guys are amazing and the unsung heroes of this mission. And I just had the pleasure of being with a few family members during the launch, and it was beautiful. We had a few words, many smiles, many tears, and it was just a joy to see these people experience their crew members achieve their dream. I will truly remember it forever, and I am so proud of you.
That's beautiful. Thank you, Jenny. Thank you for bringing this mission to the world as well. And we are counting down the hours to lunar flyby, but for today, focused on Flight Day 3 and all that the crew has to bring to us. So thank you again.
I love it. Let's do it. Thank you.
Houston Integrity, we had a great PFC on board and we are ready for the bird conference.
Copy Integrity, great timing. We just finished our discussion about OTC-1. And with such a low magnitude OTC-1 and with a low magnitude OTC-2 with a no perform of OTC-1, we are not going to perform OTC-1. Ground is going to proceed through the OpNav calibrations, and then ground will cancel the burn at MET 1 day, 21 hours, 50 minutes after the OpNav pass. How copy?
We copy snow day and understand the time is about an hour and 10 minutes from now when you're going to cancel. That was something like 21:50.
That's it, firm.
Great. Would you like us to follow along or do any steps before then?
No crew action or monitoring required today.
Okay, we will take the time to get this cabin looking good, and I think you can come back on board in the HHB camera.
Sounds great. And Christina, thank you. We'll take you up on it, and we'll be coming on board.
This is Artemis Mission Control, 1 day, 20 hours, and 43 minutes mission elapsed time into the first flight of humans aboard the Orion spacecraft, NASA's Artemis II mission. As you heard that call from the ground to the crew living and working aboard Orion, we will not be executing the outbound trajectory correction burn today. The burn was so small and our trajectory is so precise after the trans-lunar injection burn yesterday at 6:49 p.m. Central Time, there is simply not a need for that OTC-1 burn today. We were targeting 5:49 p.m. Central this afternoon for that burn, but as you heard from the ground, they will be the ones sending that cancellation, and therefore the crew will not need to take an action, and as Christina Cook calls it, have a snow day. This is a live view outside the Orion spacecraft looking at the moon, 155,860 miles away. We are about 10 minutes away from a mission briefing here at Johnson Space Center in Houston, not with the astronauts, but instead with NASA leadership. If you are watching on the NASA
Integrity timeline.
Go ahead.
Hey, Chris. Reed is complete with his EMER mask deploy for the spare mask. And we have a question about the PCD-4 when convenient. I'd also be ready to do the trash mini conference when convenient. And before we act on either of those, Reed has something for you regarding his PWD activity.
Copy all. We're ready.
For the PWD video, do you want that on an iPhone, on an HHP camera, or just whatever? Are you going to download that later? You're not looking to download it today?
Reed, we are not planning to download that video during the mission, so dealer's choice.
Okay, awesome. Thank you.
That's Commander Reed Wiseman calling down about a timelined activity for the crew today. The PWD stands for Portable Water Dispenser. And the potable water dispenser is what the crew uses to fill drink and food bags. So the request from the ground and timelined on the astronaut schedule for today is to take a video using that potable water dispenser while filling up a drink bag, filling up a rehydratable food bag. Again, this is a test flight, and so we are experiencing everything for the first time with humans living aboard Orion. So this video will be reviewed by the teams on the ground after the mission. Again, we are about 7 minutes away from a news conference here at Johnson Space Center in Houston, Texas. And if you're watching this live stream on NASA's YouTube, you won't need to go anywhere to tune into that news conference. However, if you want to continue watching this mission coverage, we do have a second stream of views available on NASA's YouTube. So you can just back out of this stream, click on that other one, and we will continue providing views of the crew and commentary here in Artemis Mission Control.
Integrity, Houston, just let us know, Christina, when you are ready for PCD-4 talk and the mini trash conference. We'll just be here standing by.
And I'm ready, Chris. Go ahead.
All right, Christina, this might be it.
And Houston Integrity, let me know if you'd like me to go ahead and start with what I've got based on the question from the flight message, flight data message. I can just get started, and then we can generate some back and forth after that.
Yeah, Christina, we will take what you got first.
All right, thanks. Well, first of all, as you might imagine, there's kind of an inrush of trash when we first get up here as we're deploying everything. So we did generate quite a bit of trash in the first 30 hours of the flight. We've been managing that by kind of finding hidey holes for it and putting some of it back into empty locations. The majority of it is in official Orion trash bags. However, some of the packing material was just packed back into some of the Ziplocs that were part of the unpackaging process. So one question we have is, our understanding is that we were basically free to put trash into open locations in CTBs as it was generated, and that the hope or priority would be locations in the D and E lockers. We haven't really opened up much space in CTBs there, like there aren't any fully empty CTBs to start packing with trash. So our ask is, do you have a recommendation for where we should start prioritizing putting the Orion trash bags as we generate them, and potentially a request to consolidate some stowage so that we can designate a CTB that's all for trash?
All right, Christina, we were just talking a little bit here. We do have a location, a desired location for this trash, and recognize I'm directing you towards a place we said we haven't deployed much already, but we have some items for you to take out. The location will be Locker D, Bag 1, Yellow Label. We'll pull out a couple of items. I'll get those to you shortly, but that should alleviate enough space to put about 3 trash bags in that location.
That sounds great, and that will cover the loose trash that we have right now on board. We have about 4 bags altogether, and we found a home for one of them.
Christina, that sounds good.
And I have a couple comments about the uphill garment trash that we have when you're ready.
Yeah, Christina, sounds good. We'll take that uphill garment trash info, and also would be looking for the location of that 4th trash bag, just so we know where to restow things.
Okay, perfect. The uphill garments, so the comfort garments, we put into the Flight Day 1 clothing bags. So we basically just swapped the locations as we changed into our Flight Day 1 clothing, and we restowed it into the locker that they came out of. Additionally, into that locker, we have our mag trash. It is currently double Ziploc bagged, but it is not in an Orion trash bag. And we'd prefer to keep it that way because we have all 4 single Ziplocked mags with their odor absorption sheets in one big Ziploc, so the 4 of them together would not fit in an Orion trash bag.
Christina, we copy that location and that request. We're going to assess and let you know if anything needs to change.
Awesome, thanks. I don't know off the top of my head the location of the 4th trash bag, but as I'm putting away the others, I'll come across it and I'll update you with that.
Copy, sounds good.
Another question when you're ready.
Go.
For all of the packing material, this would include clamshells, bubble wrap, Ziplocs, and regular Ziplocs. We basically feel like our training was that we didn't necessarily need to keep the regular Ziplocs, but that it would be good to keep clamshells or any designated unique Ziplocs that are padded for restow. So wanted to double check this understanding and get any guidance if we should do it differently. But again, what we're doing is keeping clamshells, keeping any unique bubble wrap Ziplocs. We're keeping them with
Apologies to interrupt the crew aboard the Orion spacecraft, but if you are watching on NASA's YouTube, stay tuned. We are expecting our news conference to begin momentarily.
The Artemis II mission is a test mission of the Orion space capsule.
Artemis II will be the first time we put humans on this rocket.
We're going back to the moon because it's the next step in our journey to Mars.
We were always going to the moon.
Pushing ourselves to explore is just core to who we are. That's a part of being a human.
And liftoff. We shall return.
Continuing to test out every bit of Orion.
Coming back to Earth, 7 miles a second.
When humanity sets big goals, we can bring together genius from around the world.
You have the best people on planet Earth putting this vehicle together.
That's what's up. To innovate for the benefit of humanity and to inspire the world through discovery.
And here we go.
Good afternoon and welcome to NASA's Johnson Space Center for our Artemis mission status update. We are joined today by Lakeisha Hawkins, Deputy Director for NASA's Artemis program, Judd Freeling, Artemis II Flight Director, and Howard Hugh, Orion Program Manager. We'll be taking questions from here in the room and through our phone bridge, but before we kick that off, we will go ahead and start with opening remarks. Lakeisha, go ahead.
Thank you. And welcome to the 3rd day of Artemis II. We appreciate the continued interest from around the world in the mission and in our crew. Since yesterday's trans-lunar injection burn to send the crew around the moon, the mission continues to perform well overall, and the crew is in great spirits. Currently, the crew is more than 100,000 miles from the Earth and about 150,000 miles to go away from the moon. Victor said that we call amazing things that humans do moonshots for a reason. And indeed, this is literally and symbolically our moonshot that we're in the middle of. It's great to get some very clear video and images of the crew yesterday, and the crew configured their cameras aboard Integrity, and we have some of the latest images to share with you. If you could call up the first image. This first one we got to the ground shows the unique vantage point of the crew as they look back at the Earth. It shows a backlit Earth revealing auroras as the crew heads towards the moon. It was taken by Reed Wiseman out of an Orion window, and it features 2 auroras, top right and left and bottom left, and zodiacal light, which is at the bottom right. It's visible as the Earth eclipses to sun. You know, it's great to think that with the exception of our four friends, all of us are represented in this image. You could call up the next image, please. This one shows Earth as you can see, the Terminator line. And Reed also took this photo after trans-lunar injection burn yesterday. What an amazing shot that he shared with us here. So we continue to learn all about our spacecraft as we operated in deep space with crew for the first time. And it's important to remind ourselves of that as we learn a little bit more day by day. So Judd, if you could talk a little bit more about details.
All right, thanks, Lakeisha. Let's see, so when we last left yesterday after the trans-lunar injection, the crew did some press conferences with media. They did a detailed inspection of their windows. They also had planned medical conferences, and while they were sleeping, the ground did some looking at the crew module and service module, a survey to just see how the vehicle is doing from an external view. We also continued some OpComm passes, so the optical comm antenna that we have on board to downlink high-rate images. We were able to do that overnight. This morning when the crew woke up, they had their normal planning conferences, and then they were able to do their family conferences, so they were to talk to their family. And they also did another noise characterization of how loud the toilet was. So they performed that. We had planned today a trajectory correction burn for OTC-1 is what it's called, orbital trajectory correction. The systems are doing so well, navigation and propulsion systems together, that was not needed. So we'll roll that in to the next planned trajectory correction tomorrow. And I'll hand it over to Howard to talk any specifics on the Orion systems.
Thanks, Judd. Great to be here again. Let's see, our subsystems continue to perform very well. Everything is nominal and as expected, so really good to report that today to you. As Judd said, we did the trans-lunar injection yesterday, and we get a chance to look at the data, and the propellant usage was within 5% of our predicted usage limits. So it was really good to see it go so well, and the performance for that 5 minutes, 50 seconds was outstanding. Let's see, across other subsystems, no issues relative to solar array and power generation. The air revitalization system is doing very well. We are scrubbing CO2 at very good, healthy levels. We're keeping the humidity in the right range. And the crew, obviously, you've seen, looks like they're enjoying their time in the cabin. And across various other subsystems, like I said earlier, we're performing as expected or better in some cases. Now, we are working through one issue with the SM prop in terms of pressurization. So we have helium that pressurizes the propellant tanks, basically pushes out the oxidizer and the fuel in order to make some of the major burns. And so we had to shut off, isolate one of the branches. We have redundant branches in the system. No emission impacts. This is why we build redundancy in the system. But we're evaluating that. We're looking at that. That's maybe something you heard on the loop relative to what we need to do to isolate this particular branch. The second branch is ready to go. And when I say no mission impacts, we're able to perform the rest of the burns across the mission without doing any regulation, what we call blowdown mode. In other words, there's enough helium pressure in the tanks itself that we can push out the oxidizer and the fuel without needing to regulate or require more helium from the helium tanks. So overall, our redundant capabilities are providing the coverage that we need as we move across the mission. Let's see. Yesterday also, I think somebody asked this question, but the crew was able to exercise. And I said yesterday, I think we talked a little about any performance implications on the guidance navigation control system and talked to our experts, and there were no implications on that. So performed as expected in terms of what we thought the forces that would get imparted when the crew does the flywheel, we addressed that very clearly through our design. And I'm happy to see that performance held up very well. Let's see, I have, I guess, my own couple images that Lakeisha showed you some, and I have a couple of my favorites. So the first one is just awesome to see from our spaceship. Out the window, our beautiful home planet, the Earth. I believe Reed took this picture, and it just brings a lot of great emotion to me, and to see that picture being taken. I know there's a lot of other pictures that we're going to see that are just going to be outstanding and fantastic to be able to enjoy. And then the second one, I had not seen the crew in a while. I've obviously heard them, but to see them in the interview, I do believe that I think Jeremy is too comfortable that way. I'm not sure he's working that hard, so I'm going to have to check to see if he's doing anything more than just laying there on the side here. But great to see the crew, great to see their smiling faces, and hear them talk about their experience already so far. And I can't wait to talk to them when they land home back Earth. And I think that's it for me today.
All right, thank you. We will go ahead and start our Q&A session. If you're in the room, please raise your hand if you have any questions. And if you're on our phone bridge, please press *1. We'll start right here with Mark in the back.
Hey, hello, everyone. Good to see you all again. Mark Strassman with CBS. John, I want to ask you a question, if it's okay. You know, there are millions of Americans, unlike people in this room, who are just catching up with the fact that there's a moonshot going on this week. Who knew? So I want to just sort of scoot ahead to Monday's milestone, the lunar flyby. Why does it matter? What do you hope to get out of it?
So it matters because, you know, the whole point is to go back to the moon. The whole point of this mission is a campaign to get back to the moon. And the being able to see with human eyes the lunar surface is a huge milestone, right? And that just articulates the point, you know, that we're going back to the moon, we're going to stay there, right? And so this is the first step towards that. We'll obviously build upon that. We'll get eyes on the moon, kind of map it out, and then continue to go back and enforce.
Yeah, I think maybe I'll go next. I think for us, I'll just touch or follow on what Judd said, which is the building blocks. You know, we're building a transportation system. And to have a reliable and robust transportation system, you need to test flight the transportation system. And I think that's really important. We've demonstrated on Artemis I with uncrewed capability. We've added a very important aspect of it, which is the crewed capability. And that crewed capability enables us to really understand how, when we have people in the cabin, how the systems operate. And adjustments we need to make. You hear a lot of these kinds of things that over the loop, you know, minor adjustments we need to do. Certainly engineering expertise and the design we put in has a certain understanding. But until you put people in the mix and you operate it and really understand what you need to do to operate in this kind of environment, you don't get that until you're in that environment. So I think that's really important.
Yeah, part of what we're doing is the technical aspects and what we're learning from taking ourselves around the moon. The other part, obviously, is what you talked about, which is capturing the imagination of people, right? And we have far more engagement than we had hoped to have, and we hope that it will increase as we continue to take further and further steps into this mission.
Okay, we'll take our next question here in the front, and then Eric next.
Hi, Mark Kirkman with NSF. This is probably for both Judd and Howard. I'm very fascinated, we just saw some imagery of the waste dump, and I'm very fascinated with the prediction of needing the correction burns versus what's going to be the reality. I was wondering, because there's so little available material on this on the subsystems, at least publicly available material. Can you summarize the things other than the waste dump that would affect or perturb the trajectory? What vents off of this vehicle as opposed to what we know from shuttle like FEST dumps and stuff like that? And were you surprised that you didn't need this burn? Are tighter in the prediction than is the reality tighter than the prediction was so far?
Yeah, so two parts to that question. First, so the major contributor to dispersions is what we call them, basically unplanned little tiny jets, are the carbon dioxide scrubbers. So they vent overboard, right? Vent the CO2 overboard. And so that's it's supposed to be a non-propulsive vent, but it has some propulsion to it, just like the urine vent has a little bit of propulsion to it. And so that causes minor trajectory deviations. Were we surprised that the orbiter correction or the trajectory correction was a no-burn? No, not at all. I mean, it's well within bounds. What happens really is we have a threshold by which if the required correction is low enough, that means that our fidelity on our lowest thrusting jets, our reaction control system, it's just not worth it, right? And so we'll just build up more errors and fix it on the next trajectory correction burn.
I think it's really good to see that we don't need these minor correction burns. It shows that our navigation performance and our ability to get ranging has been outstanding, and that these venting things, whether it's wastewater or the life support CO2 venting, doesn't cause the disturbances that are greater than what we would expect in terms of our performance. And I believe, I think we might have skipped maybe 2. I know we skipped 1 correction burn on Artemis 1 already. And so it's not unexpected. And so the flight control team gets an opportunity to determine when the delta V is very small, whether we actually need to execute that burn or not.
Okay, Eric, go ahead.
Eric Berger, Ars Technica. Yesterday, Howard, you made a comment about you wanted a little more humidity in the capsule, I think during the briefing, which as a Houston resident is always kind of funny to hear. But just now you mentioned that the humidity level was up and good. And maybe you could just talk about sort of the comfort in the cabin. I think there have been some questions about temperature. So kind of what temperature swings and what's the ambient temperature and sort of crew cabin comfort level?
Yeah, I'll let Judd start with the crew cabin temperature, and I can follow up. Why don't we try that?
Yeah, so we had a cabin temperature that was in the mid 70s when we first got on orbit, and then we turned off some of the shell heaters, and the temperature dropped around about 65 degrees or so, and then we understood that the crew was not comfortable at 65 degrees. So we turned some of those shell heaters on. We lowered some cabin fan speeds to try to adjust that, and we've gotten up into the low 70s, mid 70s right now. And as far as humidity, I think Howard mentioned this yesterday, but the carbon dioxide scrubbers really actually want some a good amount of humidity so that they work effectively.
Yeah, so I'll answer. We've got a lot of different kind of knobs to turn to enable the comfort level or temperature changes. For example, the pressure vessel heaters that Judd's talking about, we can go up to 85 degrees. We're not anywhere close to that yet. So that's one knob, and we have other things where we could slow down the coolant loop speed as well in terms of how we trade the heat or the coolant that's necessary to go into the cabin as well. So a lot of different options are available. And overall, keeping a steady state relative to humidity in the cabin allows us to make sure we get good readings also from the CO2 and the CO2 scrubbing associated with that humidity.
I do want to remind us, though, that this is a part of what we want to do. We want an opportunity to be able to exercise these knobs that Howard is referring to so that we have a good characterization of the system going forward. We understand the capability of the spacecraft and its systems. This is what we want.
Yep.
Okay, we'll take our next question right here.
Thank you, Mark Carreau with Aviation Week in Space Technology. I wanted to refer back to the external survey you did with solar array cameras of the Orion and the service module, just to see if you saw anything initially of concern that would have been damage to the exteriors, or it looks good.
Yeah, I have not personally seen the photos from our survey. I did watch it a little bit on TV as well, but I have not heard anything that we're concerned about, Mark. I think we will continue to go to fine detail and look at the pictures. Our thermal protection system team is doing that right now, and they'll give me a report out tomorrow morning and show me anything that they found relative to any damage. But we don't see anything relative to the back shell panels or anything like that that would cause anything of concern based on a preliminary understanding.
Okay, Jackie, go ahead.
Hi, Jackie Waddles, CNN. Thanks for doing this. Quick question for Judd or Howard. I understand that during the latest communication with crew, they were talking about mopping up some kind of leak with towels. I'm not sure I understood exactly what was going on. I'd love some insight there. And then tomorrow, there's a couple of things on the schedule I'd love to hear more about with this manual piloting, test flight test objective, and a selfie moment. I'd love some insight into what's going on there. Thanks so much.
Sure. So mopping up water. So it's not uncommon for whenever they're filling drink bags for a little bit of water to come out. The particular incident I think that the crew was talking about likely was as we were filling the contingency water bags. Whenever we had to fill them, there's a straw and a syringe, and you put a towel around it to make sure water didn't come out. There's also a feature of the potable water dispenser such that when you turn the valve off, it still dribbles out water for a little bit. So those are probably the couple of things that they're talking about. As far as tomorrow's objectives, manual piloting, so we're going to do 2 different modes. It's called 6 DOF and 3 DOF, 6 degrees of freedom and 3 degrees of freedom. It's different thruster modes of how much control that you have in all the axes and translation. So we're just it's another test objective of how the vehicle handles. And selfie, I think that's probably a selfie of the Orion vehicle with the cameras.
Yeah, very similar to what we did on Artemis I, where we had, I think, the biggest selfie stick in the world and allowed us to take all those beautiful pictures. We were originally intended to have those solar array cameras do the survey that Mark was referring to that we did today. But because we were performing so well that we were able to use one of the arrays as a selfie stick, and so that was terrific.
All right, we'll head to the phone bridge for a few questions. Our first question there is from Joseph Howlett with Scientific American.
Hi, Joseph Howlett here, Scientific American. I'm curious about how the crew is faring on board, how their spirits are. I was surprised that they only got to talk to their family now, and how did those conferences go?
Yeah, so we'll say a little bit about that. They are in great spirits, and they are really excited about the opportunity to be there and what's going on. Obviously, they've been very, very busy the first couple of days, especially leading up to trans-lunar injection. But now that we've gotten through that, that's why there's been an opportunity for them to do things like have a conversation with their families. And in terms of the great things that are going on, they did get awakened this morning with a song called In a Daydream by the Freddie Jones Band. So there's a lot of fun things going on in addition to a lot of hard work.
Okay, our next question on the phone bridge is from Micah Maidenberg with the Wall Street Journal.
Hey, I just had a couple of quick ones for Judd. Judd, I wanted to make sure I understood this lunar science observation period. So during that 6-hour period, that's when Orion's traveling around the far side of the moon for the entire stretch of that, or not? And do you know approximately when on Monday that 6-hour period begins, like in Eastern or Central time? Thanks so much.
Yes, I can get that for you. As far as what we're doing, it's essentially when we start our closest approach to the moon. It's pretty much the entirety of that day we'll be able to see the moon, and so what we're doing is we're doing visual observations, taking camera shots of the moon and the like. As far as when we start it, it's going to be UTC of around 1830 UTC on the 6th. So subtract 5, that's 1330 Central Time, and it'll be going on for most all of that day, right? Because they'll be at their closest approach and pretty close thereabouts during that entire time.
Okay, we'll take one more question on the phone bridge and then back here in the room. Our next question is from Marcia Dunn with the Associated Press.
Oh, hi.
Hi, thanks for taking this. Probably for you, Judd. NOAA just issued a geomagnetic storm watch, G2, coronal mass ejection. I know you guys are watching this throughout the mission, but will this one, it doesn't seem to be too bad, but will the crew be doing any precautionary measures because of this? And same question from yesterday. What's the latest revised numbers for closest approach to the moon, all the numbers and distances? Thank you.
All right. Yes. So we do have our radiation specialists that monitor all of that stuff. And if any of the sunspot coronal mass ejections happen from the sun, if they get to be a concern, then obviously we have mitigations, radiation shelters we put up. We do not expect that from this one, but we are continually monitoring that. As far as the updated numbers, I've got in statute miles, should be 252,757 statute miles at our furthest distance from the Earth.
You're not going to convert that to nautical miles?
I think Howard's got an app for that.
Yeah.
Okay, we'll take our next question right here. Go ahead.
Hi, Lauren Grutch from Bloomberg. Thanks so much. I just wanted to go back to that helium issue you were talking about earlier. You said you isolated that one branch. Just wondering if there's any concern if the second branch that you're relying on now has a similar issue, or is that redundancy you mentioned earlier, would that kick in for this problem? And then I've just been listening to the loops, and it sounds like there have been various, sensor issues or issues that are cropping up that don't seem to be an issue, like there was a suspected cabin leak, caution alarms that were coming on, but then turned out to be false alarms. I'm just curious if you're sensing any pattern with that, or is that just random glitches for a test flight like this?
Yeah, I'll start. The other second branch on the oxidizer side is performing very well. No issues there. And so, again, that redundancy is there. And I said earlier, we do not need to regulate either on that line either for the rest of the burns. So I think both redundancy paths are in good shape. I would say, and I'll let Judd maybe talk some specifics. In general, Lakeisha said earlier, we're learning from this vehicle. And the caution warnings are based on, limits. And those limits are established jointly with the engineering team and the flight operations team. However, we have to operate in the environment. We have to, account for variations. And so I think sometimes we don't get it fully right. And when we don't, we correct it and we'll make adjustments real time where we can. And if we need to, we'll make adjustments for the future as well once we get all the data. So I think all those things are part of the learning that we're doing, and certainly good to keep the team on their toes and making sure that we're not only watching the systems very carefully, but we understand what the system is telling us, and we're adjusting based on what we understand from the data.
Yeah, and I'll add to that. So it's important to remember on Artemis I, we didn't have a caution and warning system. Because we didn't have a crew on board that we needed to alert them about, right? And so while we did measure, all of the things we did, we obviously didn't have an ECLIS system on board either, so that we knew what the behavior of that was going to be. So this is all part of exactly what Lakeisha is talking about. This is learning. This is learning how the vehicle operates with the human system in the loop, right?
Okay, we'll go to Bill next.
Hi, Bill Harwood with CBS News. This is a question I get asked a lot, and I realize that it depends on who you ask how it gets answered. But, given all the Apollo missions, the satellites that we've had around the moon at much lower altitudes than these guys are going to be at, the question I get is, what do human eyes really bring to this? Even if they've got nice cameras in their hands, they're a long way from the surface. 4,000 miles. What is this bringing that we don't already have from satellites and past missions? And I'm not saying that as a devil's advocate. I'm curious how you frame that in terms of the priorities of the mission. Thanks.
You want me to first? I can start, yeah. So my understanding, talking with the scientists, is that your eyes, the human eyes, can resolve details much better than taking a picture and then looking at the picture, even with a telephoto lens. And so that observation that the scientists are looking for is really what's key, even from as far as away as you mentioned, 4,000 miles. There are still things that the human eye can pick up with granularity that are important to the science community. Now, I can't talk about what those specific things that the science community is looking for, but that's my understanding.
Yeah, I think I'll try to maybe repeat what I said earlier. When I tell people this, and it's really purely from a spacecraft side, when we talk about wanting to have a moon base, wanting to have people on the surface of the moon or other planets, you need a way to transport people safely to that particular domain. And to me, it's very important that we do everything we can to understand and provide that capability in a robust and reliable way. And you have to walk before you can run. And I think this is very important in our step towards exploration, is learning, as we talked about earlier with all these questions relative to our subsystems, learning about how the subsystems operate in space. How do we put people in space, especially to the moon first? We haven't done that in over 53 years. This is a whole new generation of learning that we're trying to do. Certainly we learned a lot from our Apollo, I call giants, but we have our own learning to do, and we're trying to be more capable, and we're trying to provide more numerous opportunities to go to the moon so that we can put people down on the surface.
All right, we'll take our next question right here. Go ahead.
Hi, Michael Adkison, Houston Public Media. I know you guys are all too familiar with the Apollo 8 comparisons to this mission. They obviously did their Christmas Eve broadcast, and Sunday is Easter. We're in the midst of Passover, and Ramadan even was a couple of weeks ago. Are there any plans to do any sort of downlinks to mark the occasion or anything like that?
There will be an opportunity, obviously, to hear from the crew, and we will be having a conversation in terms of what they intend to share with us. They are always inspirational in their communication with us, and we're really looking forward to that.
Okay, we'll take our next question right here in the middle.
Hi, T.G. Mascara with the Epoch Times. Thank you so much. My question, Howard, what specific things have exceeded your expectations in terms of the Orion spacecraft?
Well, that's interesting. I would say that, just how happy and how well trained the crew is and our teams are to just work through just minor issues that we've had. To me, it's not so much an exceedance of expectation. I expect that, but just to see it in play, just to see how well that's working out. Of course, I expect our spacecraft to perform, but you never know. This is why we have a flight test, and it makes me very happy to see that although we have some minor issues to deal with, the team operates very well with the crew, both on the ground collectively between our mission evaluation room, our flight control team, and with the crew together, working together. And of course, the spacecraft is responding in a way that, of course, we knew about from Artemis I. Every spacecraft is different, but the process is the same, the rigorous testing that we do and the analysis we do. And so I would say that it's always good to beat expectations.
Richard Two of the Post newspaper. A question for Judd, talking a little bit like a different aspect of this, so that with the MCC. Can you talk about so many moving parts make this mission successful coming out of that department? What's the tone and the consensus of the controllers, the directors, as they see this mission transpire, and what are they thinking as far as how things are going so far in the mission?
So my sense is that there's a lot of people that are very excited, right? And excited not only for the overall general, objective that we're going back to the moon, but also just from, there's a lot of time that people have invested in training for this mission, developing the mission, being able to work well with all of the teams together, and to see that come together. I think there's a lot of excitement there, and it shows.
Going off that question, just curious, the technology's changed so much in mission control from the Apollo days to Artemis. Is there anything that you all have learned during this mission? Have you made any changes in mission control? We see the astronauts are making changes on the fly. I'm just curious to know if any changes are being made in mission control as well.
Yeah, I mean, I think you hear it in all of the funnies we see with sensors, the way they behave, the way the systems behave. That means that we're all reacting to that, and we are developing on the fly different ways than we originally thought how we would operate the vehicle. And so that is always an iterative process, right? And I think you're seeing demonstration of that in real time, and that we're iterating on not only learning about the vehicle, but also how to iteratively operate the vehicle as well.
Okay, we'll take another question right here in the room.
Yeah, hi, Beverly Casillas for Space Scout. Thanks again for doing this. Two quick questions. The first one, so we heard that the optical communications demo is already being used to downlink some imagery from the spacecraft. It sounds like that happened overnight. Are there any plans to potentially do any transmission of live video during the mission? And is that something we would get to see, if so? And then a second question, because it sounds like Orion's maneuvering has been really precise during the mission so far, what are you hoping to learn during this mission about guidance and navigation and PNT in the lunar environment? And is there anything that you're kind of already learning about that process? Thanks.
So I'll take the first part. For optical comm, the way the trajectory is set up, unfortunately, the only passes that we have with Goldstone are when the crew is asleep. And so anything that we have downlinked would be just video that you're already kind of seeing, higher resolution of the spacecraft looking back at either the moon or the Earth. And so for that purposes, we're really going to just use it for high-res video downlink. And then your second question.
I think I'll take the.
Yeah, why don't you take that? Yeah.
Can you repeat your second question? I think you said something. Perked my ears. Guidance, navigation, control. So. Yeah. Can you repeat that, please?
Yeah, I was just saying, because we've seen how precise the kind of trajectory planning has already been with, not needing to do this correction burn. Have you been having any learnings already about navigation and PNT with the Orion spacecraft and like ground systems during this mission? And is there anything at the moon that you're also hoping to kind of learn and experience on that front?
So, we're using very traditional navigation instruments, so star trackers, the inertial measuring units I talked about yesterday. I think those are, we expect them to be precise. They're tried and true navigation instruments or sensors that are on a lot of spacecraft across the board. I think one of the things that we may have not talked about a lot is we have a capability on Orion to navigate without ground comm. And that's the optical comm system, optical navigation system. And that's a camera-based system that gives you a really good enough navigation knowledge to be able to return the crew home and perform the mission. And so that's something that's a new capability that we're very interested in. I know the navigation team is certainly very interested. We did do some testing on Artemis I, and we learned a lot from that. We'll learn a lot from this because it basically takes pictures and translate that size of the moon or the Earth, depending on which way you're pointed, and gives you navigation knowledge from that. So again, that's a tool that we expect. And of course, as an old controls guy, control systems, ability to have good latency or no latency potentially, and ability to fire the jets when you need it, the combination jets you need them based on your offset center of gravity and where you are in terms of your mass properties are really a great knowledge across the board of understanding. We put a lot of effort into protecting for a lot of dispersions, as Judd's talked about previously. And of course, when we encounter those dispersions, being able to control our spacecraft through them is really important as well. So all that we'll be learning. We will learn a lot, even though we have very good instruments, even though we know we have good control laws, we've implemented algorithms. Every mission is a great learning event, and it's really great to see that the precision of the work we put in is being replicated on orbit.
And I would add to that, in addition, as good as the sensors are on Orion, we still have to do ranging of the vehicle to update its state knowledge every once in a while. And so as a lessons learned from Artemis I, we have a new suite of tools on the ground that are able to process that ranging data. And also to hopefully, what we're hoping to learn is to back out all of those, minor dispersions from, non-propulsive events that are a little bit propulsive, so that we understand that can characterize all of the error sources of the navigation state.
Okay, we'll take another question here in the room, and then we'll go back to our phone bridge. Go ahead.
Thank you. Tarek Malik with Space.com. I think for Judd, there was discussion yesterday about how Flight Day 3 was a big change of pace for the crew after the first kind of action-packed couple days. And I'm really curious how, I know they had CPR demos today, they had lunar science preps today, how that change has gone. And then I know that tomorrow they've got some scheduled time, at least 20 minutes, to take photos of celestial bodies. And I'm just curious, if it's not the Earth and the Moon, what else might they be taking pictures of out the window in their personal time there? Thanks.
Yeah, I mean, I think you probably saw in some of the videos the crew has a lot more time on their hands than they did in the first days. We were able to present them to you and have them talk to the media. As far as the pace, yeah, I think you can probably tell from the downlinks that the pace is quite different than it was the first couple of days. As far as celestial, I mean, they're taking pictures of stars and moon and sun, right? So anything they can see that is of interest.
Okay, we'll head back over to our phone bridge. Our next question is from David Denault with About Space Today News. Go ahead.
I need to do a follow-up regarding the cabin temperatures. Has NASA determined a desired temperature and a desired humidity? And is there any relationship to that with the carbon dioxide?
As far as the desired cabin temperature, that is up to crew discretion, right? And so we're simply going off of what feels best to them as a consensus for the 4 members of the crew members. And humidity, we have to have some amount of humidity. I think we mentioned earlier for the carbon dioxide, we don't want it to be Arizona dry, I think is the term to use. We certainly want, but obviously the crew doesn't want it to be Houston humid either, right? So,
yeah, that's about right. Yeah. About 70s and about 25%, somewhere around there.
Yep.
Yep, they're comfortable.
Okay, we'll take another question from our phone bridge. Our next one is from Allison McGraw. Go ahead.
Hi, Dr. Allison McGraw, Mysterious Meteorites. Congratulations on the continued success from the giant leap for planetary science. My question is, given the crew's training with the CLO, or Crew Lunar Operations, what geology or image targets are first to be taken of during the lunar flyby? Thank you.
I think we heard your conversation about images supporting geology. Yeah, so the crew is definitely going to be preparing themselves during the lunar flyby and during the time that they are going around the moon to take images. They are actually working now with the science team that has gotten underway, and they are doing preparations and working together to figure out what will be of interest and what they expect to see on Flight Day 6. And so that coordination continues as guided by our science team.
Okay, we'll go ahead and come back here to the room. If I can get a show of hands, how many more questions we have. Okay, we'll jump right over here. We'll take a few on this side, and then we'll come back over to this side.
Hello, Dan Lenahan from the Naval Postgraduate School. You've talked about this mission being a flight test program and an envelope expansion. And with the importance of the International Space Station, can you maybe talk about how the systems in Orion were originally kind of tested out prior to this mission in order to kind of succeed?
Yeah, I'll start with the Universal Waste Management System, or the toilet. The same toilet was flown on Space Station. I think the crews there were able to operate it for roughly about 2 weeks, if I remember. And so that was a really good, important test in a relevant environment against our toilet that we would be able to fly to the moon with. So that's one piece. I don't think there's probably smaller equipment, like, for example, the CO2 removal system. The heart of it is these amine beads. They absorb CO2 and then we vent it out. The same technology is on the space station, different way on how they approach it, but very similar in terms of absorbing and desorbing of the CO2 that comes from us humans. And that was also really good foundation to stand on and our confidence associated with ability to remove CO2, although in a different manner on board our spaceship. So those are probably the big items that I would translate between what we've learned from Space Station and what we've applied for Orion.
Okay, we'll take our next question right here and then right behind you after.
Thank you. Jonathan Seri with Fox News. I'm interested in the medical equipment on board. How did the CPR demonstrations go? How did the other demonstrations go? And then if you could explain Avatar. I understand what it is, but I don't understand how the chips interact with the cell samples. If you could school me on that.
So they haven't done the CPR demo as of yet, or at least as I started the conference. So that's later on today. Avatar.
So we don't have a science representative here with us today, but as best I understand that Avatar is actually analog tissue samples from the crew members, and they have been brought on board, and there's going to be an expectation that they'll be evaluating those samples for how they react to the environment while they are on this mission, including reaction to exposure to radiation as well. And so when it gets back, we'll be very interested to understand what they learned, both from the crew themselves as well as their avatars.
And Jonathan, if you need anything else on that, we can get it to you after the press conference.
That'd be great. Thank you.
Robert Coppinger, the British Interplanetary Society's Spaceflight magazine. Do you have any information on the status of the CubeSats that were deployed?
Sure. All 4 CubeSats were successfully deployed on the planned timeline about 5 hours after launch. There has been positive communication with 2 of the CubeSat satellites, the one from Saudi Arabia as well as the one from Argentina. And then in terms of how they're faring, at this point, it would definitely be best to reach out to the payload owners in terms of how they're doing. But they absolutely were deployed as expected.
Okay, we'll take another question over here, and then we'll head back over to the right side of the room.
Hi, Katrina Miller from the New York Times. Any milestones we can expect for the rest of today? What are you 3 focused on for the latter half of day 3?
Sure. As was previously mentioned, we have the CPR demo. We'll have another press conference with the crew. They'll go look at do their med kit evaluations of what they have on board. Also, we have, as far as communications with the Deep Space Network, we're going to test out again the emergency comm mode in a more deliberate fashion. And I believe Jeremy has a press conference with so it's a CSA press conference, and then some more planned medical conferences.
Okay, we'll take our next question from Will. Go ahead.
Hi, Will Robinson-Smith with Spaceflight Now. Thank you all for the time today. Question for Howard. It might be a little bit early to ask this, but from the performance you've been seeing in Orion so far on hardware and a software side, do you foresee any notable changes or updates to hardware or software for the Orion spacecraft that will fly Artemis II at this point, besides the heat shield, of course? And then the images that we've seen so far for whoever wants to take this so far have come from Reed Wiseman. Don't know if that's just happenstance or, if the other crew members are getting good pictures, but will we see a variety of the photography skills in the days to come? How is that kind of being decided and divvied up at this point? Thanks.
All right, I'll take your first question. I think walking into this meeting, I think, or this mission, and hearing from you here relative to just the software changes we're talking about are going to be caution warning for sure. The limits that we put on, we're going to learn a lot from this mission. So there's going to be, I call them software. You probably don't think of them as software, but really data values for limits. So those will be changing for sure. We have not seen any issues with our flight software. The actual code itself. Of course, we'll learn a lot more as we go forward next few days. Hopefully, we'll find nothing. But we don't. We'll make some adjustments if we need to for Artemis III. Our software development is still a few months ahead of us in terms of completing it. We've got a lot of the software done already. Of course, we've got a lot of software for Artemis II. From a hardware perspective, there's a lot of learning. These, I would say, minor issues that we've encountered and these isolation valves, et cetera, we're going to go check those out and try to get the root cause. And if we have any things that impact our ability to fly at Artemis III, we will work that.
Hey, Howard, why don't you also touch on the different camera capabilities to include the mobile phone cameras, et cetera?
Yeah, so from an image perspective, before maybe Judd talks about who's going to take pictures, if you might or may not know that we have iPhones on board for the crew members, and they're able, not only the Nikon D5s and the Z9s that we have on board that we preloaded already, they were able to also take some iPhones as well. That's what Lakeisha's referring to. And so they'll get some great images from all those cameras. And I'll let Judd talk about who gets assigned the best pictures. I don't know.
Yeah, I mean, I think it's probably just happenstance that you've seen, Reed's pictures. Every one of them are going to be taking pictures, and I'm sure once we get, are able to downlink all of the pictures, I think you will see a suite of pictures from all of the crew members.
Okay, it looks like we have one more in the room. Do we have? Okay, we'll go ahead and take one from you. And then we'll head back over here. Thanks.
Hello, Kaya Burgess from the Times of London. Moon. Is there any plan in the future to try and overcome that for future missions, to try and use kind of satellites at Lagrange points or wherever it might be, so that in future that communication behind the moon will be possible and you will never be out of signal in the future? Obviously, it's been possible for Chinese missions that have landed landers on the far side. Is that something that you will be looking into?
So I'll just mention, as part of the administrator's Ignition initiative, he has talked about all kinds of different capabilities that we are going to try to add in a stepped approach to include capabilities on the surface on the moon, as well as communication capabilities. And relay capabilities will be absolutely a part of that for supporting us in the future.
Okay, we have another question right here. And do we have any additional questions after this one? All right, one last question in the room.
Thank you. Rod Pyle at Astro Magazine. A similar question. How long do you expect the blackout to be during the flyby? And given that there's no burn back there, is there any reason to be chewing our pencils? And is there anything to learn from the timing when they come back out and you reacquire signal? Thank you.
So as to your second question, no, physics takes over, and physics will absolutely get us back to the front side of the moon. Let's see, I don't think I have the timing yet on this for how long we're going to be out of comm, but I can get you that.
Is it about 40 minutes?
Yeah, it's around.
Somewhere in that vicinity? Mm-hmm.
Yes, it is 40 minutes. All right, well, it looks like that's all the questions we have for today. Thank you so much for joining. We'll see all of you back here again tomorrow at 4:15 for our next mission status briefing. As always, you can keep up with all the latest news and events during the Artemis II mission at nasa.gov. Thanks for joining.
Hi, everyone, and welcome back to Artemis Mission Control here at Johnson Space Center in Houston, Texas. This view coming to you live from one of the solar array wing cameras on the Orion spacecraft, looking at the European Service Module and the Orbital Maneuvering System engine, also known as the OMS. We are 1 day, 21 hours, and 49 minutes into the Artemis II mission, the first flight of humans aboard the Orion spacecraft. Orion and her crew, Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen, are now 111,482 statute miles from Earth and continuing to increase that distance as we continue to grow closer to the moon, 153,763 miles away. We've just wrapped up our daily press conference, during which mission management is able to answer questions from the media. We have another one of those scheduled for tomorrow afternoon at 3:30 p.m. Eastern Time. We're live here in Mission Control Houston 24/7, providing updates as the crew continues their work aboard the Orion spacecraft. One of the most major events for today was the OTC-1 burn. That was the Orbital Trajectory Correction 1 burn. That was a timeline to happen at 5:49 p.m. Central Time. However, that burn has been canceled because there is no need to correct the trajectory of Orion at this time. That burn follows the trans-lunar injection burn at 6:49 p.m. last night. The trans-lunar injection burn took us out of high Earth orbit and sent us toward the moon. It also commits us to a splashdown on Flight Day 10. Because that burn was so precise, teams were able to cancel the OTC-1 burn today. And a quick correction, the briefing for tomorrow afternoon is at 5:15 p.m. Eastern. This is the channel you'll need to look for that on, and we will continue our communications and coverage on our second YouTube stream. However, we are back here with the crew for the rest of the day. They woke up at 12 p.m. Central Time and have since then configured the cabin. They also spoke with the teams on the ground for the daily planning conference, and we got some great views inside the cabin. With that burn cancellation for today, the crew now has a little more free time on their schedule after having a very, very busy first two flight days with launch on April 1st and trans-lunar injection burn on April 2nd. They do have a handful of timelined events for today, however, including filming a video of the potable water dispenser. This is how the crew accesses water during the mission. There are 4 water tanks on Orion, and they are able to fill drink bags as well as rehydrate the food that they eat while on the mission. As this is the first time we have crew living and working in Orion, the team's timelined an event for them to video themselves filling up those drink bags, filling up a rehydratable food bag to help us understand how the system is working in orbit. They will review that video once the crew has returned to Earth. There are a handful of medical devices on the spacecraft as well, and so other things the crew will be working on today is checking out those medical devices. One of those is the electrocardiogram device. They'll be able to check that out on one of their fellow crew members. Later on in the day, they will also activate and check out other diagnostic devices of the Orion medical kit system, including the blood pressure monitor, thermometer, stethoscope, and otoscope. And staying in that medical timeline, the crew will also be conducting a CPR demonstration. They'll be using their medical emergency procedures to simulate methods to treat an airway obstruction if one were to occur on Orion. A key feature of many of these events, as mentioned with the potable water dispenser, is that these will need to be recorded. These will serve as training videos and also help teams on the ground learn how to best prepare the spacecraft for future missions. Later this evening, it looks like about 10 p.m. Central Time, the crew will also work on configuring the cabin for lunar flyby. Now, they will deconfigure it because flyby is not until flight day 6, but this gives them an opportunity to practice their positioning throughout the cabin as they prepare for flyby.
Integrity, Houston, with a status and a timeline, Delta.
Go ahead, Chris.
All right, we wanted to let you know that we are stepping into our burn cancellation procedure here from the ground. We have attempted to suppress any expected caution and warnings associated with that. Just want to give you a heads up. And then we'll let you know when we have a new active burn plan. The other piece is we'd like you to give us a call prior to the CPR demo. Consider that a hard scheduled activity for now so that we can position the saws. How copy?
Copy all, and let me know when you're ready for me to start exercise.
All right, Reed, I will let you know.
As previously mentioned, we are expecting the crew to get into the CPR demo later today. That won't be until just before 7 p.m. Central Time, but the team on the ground has asked the crew to let them know before they start that demo so they can park the solar arrays. Reed Wiseman also called down that he is standing by to begin exercise. That's another opportunity for the team to park the solar arrays, and by doing so, it keeps any movement that happens inside the spacecraft from damaging those arrays. We did see some movement yesterday while Commander Reed Wiseman was exercising. The crew uses a small flywheel device. It only weighs about 30 pounds in comparison to over 4,000 pounds of equipment on the space station. And the crew is timelined to exercise for 30 minutes a day to help maintain their bone and muscle strength. This, a live view of the Artemis Flight Control Room here at Johnson Space Center. Down toward the bottom of your screen, Capcom Chris Birch, NASA astronaut who you've been hearing speaking with the crew, and next to her, Capcom and Canadian Space Agency astronaut Jenny Gibbons, also a backup flight crew member for Artemis II. Near the top of the screen, Flight Director Jeff Radigan, and to his left, Flight Director Diana Trujillo. On the left side of your screen, a live view from the Orion spacecraft, now over 112,000 miles away from Earth. And that is our little crescent Earth over to the right.
Integrity with a mag stowage follow-up for Christina.
Go ahead.
Christina, in your last report, we copied 2 levels of containment for those mags, and we need 3. So our suggestion was to put in a trash bag, if able, or another Ziploc, unless you can correct me and say we've got 3 levels of containment.
We'll go. Thank you.
Thank you much. And Integrity, read is go for exercise. We're configured.
Just as everything is properly and precisely tracked aboard Orion, there are procedures for everything as well. So whenever disposing waste, the crew is calling down, they need to track exactly where that is stowed and how. Even for Commander Reed Wiseman cleaning the windows last night, there are specific ways to take care of all systems aboard the spacecraft, and so it's important that the crew checks with the ground to make sure that they are properly caring for Orion.
Chris, I copy on exercise. I'll be starting in about 5 minutes.
Copy, sounds good.
Commander Reed Wiseman calling down that he is planning to start exercise pretty soon. And yesterday we did see some motion as he was exercising. We will look for that again here on the left side of your screen, a view from Orion looking at the European service module and that orbital maneuvering system engine. Again, we don't expect to fire the orbital maneuvering system engine again after the trans-lunar injection burn. That was the final major burn for that engine. But this is the engine that would be used should we have an abort of the mission. However, everything's still looking great for Orion and for our 4 astronauts on the Artemis II mission.
integrity regarding the enabled caution ORD guide unconverged. Unexpected from us down here, probably related to our recent burn plan uplinking. No crew action. And as we're performing an attitude maneuver, we're going to need Reed to stand down from his exercise until we can get the saws repositioned.
We copy standing down from exercise and copy your words about the caution as well.
Those calls to the crew as they received a caution on their displays for orb guidance. That's due to the cancellation of this orbital trajectory correction burn. No action called to the crew. Again, we canceled that orbital trajectory, outbound trajectory correction burn due to having such a precise trans-lunar injection burn. This other burn today would have only been 8 seconds long and was deemed unnecessary. As we are currently maneuvering the attitude of Orion, Commander Reed Wiseman was also asked to hold on beginning his exercise due to the need to maneuver the solar arrays as well. They will then park those solar arrays and put Orion in the proper configuration for Wiseman to begin exercise.
Hey everyone, I'm back. Thanks for hanging out while I was gone. So I didn't end up asking the question about the coronal mass ejection, but Marcia Dunn with the Associated Press did. And then we did get somebody else asked a question about the optical comm system. And so that Judd, who's the lead ascent flight director, and I guess he's, at least for the first few flight days, is going to be the mission operations directorate, or is it the flight operations directorate? I always get those mixed up. But he's the rep at these news conferences / status briefings. But I did get a chance to ask Judd after the briefing what the acronym PPC stands for. I hope I'm conjugating the middle one right. It is a private conference. It's a private, I think, private psychology conference. So they would be talking to a psychologist, as opposed to like with a private medical conference, they would be talking to a medical doctor. So it's just making essentially instead of a mental health conference at private for the crew. And I guess it would be kind of interesting to, but probably not highest priority to of the topics to ask about. I'm trying to think if there was anything else. Oh, well, not directly related to Artemis II, but certainly not completely disconnected from Artemis II, but it slipped my mind, and because I have a few other housekeeping chores that I have to take care of, and there's I think one left, and I'll need to go back, or I will need to duck out again for a little while to take care of that. Hopefully, I can take care of it without having to completely leave, but it's really just a question of how much time it takes to get it done. So, but yeah, it was a and that thing is that the fiscal year 2027 budget request was released. I'm not sure when, but the timing, of course, is coincidental, but it'll be interesting to see how much it is overshadowed by this. It won't be forever, though, because there will eventually be hearings, and it will be interesting. I haven't even had a chance to take a look at it, although I've seen a couple of remarks, and so what I thought I would do here when we get some more commentary from the public affairs officer,
mission planning officer
like
here in Artemis Flight Control in Houston, Texas, reports that the crew is go for exercise as the solar arrays are now in place. We'll be looking to see if there's any movement while Commander Reed Wiseman begins his exercise portion. Orion is currently 113,922 miles away from our home planet, 152,000 miles away from the moon. Capcom Chris Birch also called up confirmation about that caution that the crew received about orb guide that was due to the cancellation of the outbound trajectory 1 burn. And of course, no action for the crew. Canadian Space Agency astronaut Jeremy Hansen answering Capcom Chris Birch's call to conduct an AGA reading. That's an anomaly gas analyzer reading. That device must be powered on 5 minutes prior to taking a reading, and they request that the crew does so before exercising. Obviously, this is the first flight of humans on this spacecraft, and therefore it's also the first flight of an ECLSS system, environmental control and life support system. By taking these readings inside the cabin, teams on the ground are able to determine how that ECLSS system is functioning and what amount of gases are inside the cabin. The numbers you heard Hansen reporting are in parts per million.
Well, definitely an interesting budget request. It looks like. Let me pull it up here. It'll take a while to completely digest, but I mean, if you just look at the top line numbers, it's you can see some of the same themes that we saw last year. So, as an example, the Science Mission Directorate budget is once again cut in half. So, the Congress enacted a $7.2 billion top line for that directorate, and the White House is proposing to cut that down to $3.9 billion in fiscal year 2027. It's probably about the same as they proposed for fiscal year 2026. So, it's hard not to be at least, I mean, not even just a little cynical. But I don't know that I would say completely cynical, but it's hard not to be at least somewhat cynical about some of these things when you actually see the numbers. And even though the Science Mission Directorate funding is not directly connected to Artemis. Artemis is mostly funded out of the Exploration Systems Development Mission Directorate. It indicates a willingness to do something like that, which is basically to cut something in half. So it's going to be interesting to see how Mr. Isaacman justifies that level of funding. I'm sure that the budget request documentation includes some level of justification as well. So they will advocate for their, but it will be interesting to see as it was last year, what the reaction will be from Congress. And it probably won't be, the reaction probably will not be, it'll be similar to last year. So the only part, because it's this odd dynamic of the general politics and the way that the political parties are divided, and then the politics within this area, within NASA, they don't divide along the same lines that often. But because of the political dynamic, and even with all the other stuff going on today, not just today, but just in general, I suspect the only politicians who will be comfortable criticizing this will be the minority party, the Democrats. It will be interesting to see if there's any veiled criticism of this from the president's party. I don't recall there being much in terms of the rhetoric, but it's just like last year. It's going to come down to what's in the bills that get passed. And to be fair, it's possible that they don't pass a budget for fiscal year 2027. They just pass another continuing resolution And if that's the case, then, well, things will still be as messy as they were last year, because then it's going to depend on how NASA chooses to interpret that. And then on the flip side of it, it also is how does Congress choose to, how do they choose to engage with NASA in terms of NASA's operating plan? And of course, all of that stuff is, generally speaking, kept private. I'm just making sure that the stream is mostly live.
This is Artemis Mission Control. As you can see, some motion on your screen from this camera on the solar array wing looking back at Orion. We are expecting that to be from Commander Reed Wiseman, exercising yet again. The crew's timeline to exercise 30 minutes each during this mission. This keeps their bones and muscles strong while in the microgravity environment.
Each day.
This type of motion doesn't damage the spacecraft, but the solar array wings are locked and parked to keep them from being damaged by any loads imparted from this movement.
See if I can bring this up relatively quickly. So this is not the entire, because well, let's see. Let me see if I can. It does have the highlights though. So this was released today. No, this is gone. Yeah, there we go. These are this is just at the directorate level. So exploration, it's hard to see the changes in the exploration budget here, but you can see, so we see the same thing as last year. So the NASA budget goes from, the top line goes from about 25 billion to a little bit under so 24 point, about 24.5 billion to under 19 billion, and that's in the ballpark of what they proposed last year for the NASA top line. And so then you can see the exploration. You can see the I'm sort of looking at this in a smaller screen. But you can see the shift in emphasis from Moon and Mars transportation systems, which are the government systems, to Moon and Mars systems development. Although there's, within the transportation system line, there's that transition from Orion and SLS and EGS, exploration ground systems, to the commercial transportation. But then you can see the science. Pardon me, the science budget. It would be useful contextually to actually show the fiscal year 2026 budget request, and I may do that at some point later, because the FY 2026 request and the FY 2027 request are in the same ballpark. And so aeronautics is cut. I don't know that it's cut quite as much as last time. That would be something that would need to be double checked for sure. And then again, the whole STEM engagement, same as last year. They proposed terminating that, and they're proposing terminating that again. So let me go find the exploration stuff, the Artemis specific stuff. Because it gets a little complicated, especially with Space Launch System 4, because of the Big Beautiful Bill. And of course they're now, I'm not sure why, but they refer to it differently now, but it's the same bill. If you want it, what is it? Public Law 119.5, I think. But that's what, that is what I guess that name got to be a problem. So was not popular, so they changed the name. But, again, that's just the packaging. The interesting thing is that I didn't hear. I'm trying to remember who mentioned it. So I mean, I don't know if I sort of mentioned it when I was talking, introducing bringing this up, but that's what happened. There's so many things going on that I forgot about this until I heard somebody talk about it when we were sitting in the auditorium in the briefing room, and somebody mentioned it. I was like, oh yeah, So it's Good Friday, and there's a lot of other things going on in the world, and Easter's on Sunday, and they're also releasing the budget. So, and Artemis II is going on at the same time. So yeah, I remember it earlier in the week before the launch, but it had slipped my mind too, and I did not hear a lot of people talking about it. But somebody mentioned it, and I can't remember who it was, but it's. As I mentioned, there will be hearings in the House and the Senate. Well, I shouldn't say that actually. There would have been hearings in the House and the Senate last year. Maybe they didn't do those because Mr. Isaacman was in the nomination process, and then that was tumultuous in and of itself. So there never, as far as I know, there never were any budget hearings for the 26 budget, but I would still expect that they would plan on it, and then we'll just have to see. I don't know that that's necessarily going to happen.
This is Artemis Mission Control, 1 day, 22 hours, and 37 minutes into the flight of Orion and the Artemis II crew. NASA NASA astronaut and commander of the mission, Reed Wiseman, continues to exercise on the flywheel device inside Orion. That's why you're seeing some of that motion right there. And earlier today, the team decided to cancel the outbound trajectory correction 1 burn. This was going to be a small burn to keep Orion on the path to fly around the moon. However, our trans-lunar injection burn was so precise that this correction burn was not necessary. So the crew has a little bit of free time back on their day. Coming up in just a couple of hours, the crew will get into their midday meal. The food the astronauts eat plays a key role in maintaining their health and ensuring they can perform their mission objectives to the best of their abilities, and it's also something they enjoy sharing together. Long before launch, our teams here at Johnson Space Center start preparing, so this crew has everything they need to enjoy their meals. Let's take a look.
Around the moon meal.
Around the moon meal. What would you eat? Cheese? Can you think?
Oh my gosh. That's clever. What do you think?
All right, describe. My name is Christina Cook.
And I'm Jeremy Hansen. We're crew members on the Artemis II mission flying around the moon. And when we fly around the moon, of course, we're going to be taking some food with us.
That's right. This is how to eat in space. Here we are in what we call our food lab at NASA Johnson Space Center. We come in here quite often to sample space food. The neat thing about the food selection is it is so diverse. Different entrees that you wouldn't imagine can be rehydrated and actually good in space are completely fair game. And it's pretty awesome.
We came in for Artemis to do this. We got about halfway through the first session and we're like, we're not really sure we're going to have time on board to warm this stuff up. We talked a lot about day one. It's a long day. It's hours before we even leave the launch pad on our way to space. And then when we get to space, we have a lot of important events that day. We just did a sim yesterday where lunch is scheduled. It's
midday meal.
Yeah, midday meal for all 4 of us. And so those would be great moments, I think, in our mission to have prepped some food and sit down or float as a crew and just have a joint meal.
For sure.
I think that'd be fun.
My name is Shulei Wu. I'm the food system manager for ISS and Artemis. The food lab at Johnson Space Center, that's where we make and package most of the space food, and also where we will be making all the food for the Artemis missions. Food is a big part for our crew members. They provide the nutrition, the calorie, micronutrient for crew members, but also boosting crew morale. It's very important. There is always a lot of steps, very strict steps for us to follow to making sure the food we provide are consistent and meet all the food safety, nutritional requirements, and most important, also need to taste good. The other strategy is always promote the variety because everybody's food preference can be very different. Therefore, the more variety we can have, the better to meet the needs of the astronaut group.
They bring out these little tiny samples of each food, and you're like, oh my gosh, I thought we were having lunch. And then by the end, there's so many space foods, and every time you leave, you're like, I am so full.
I'm so full, I'm in pain.
And you just rate them like, I love this, I don't want to eat it, I'd eat it if you tell me I need it. Because what the food lab does is they take all your preferences, but they're also like good parents and they're like, you need a well-balanced diet.
Exactly. They were like, no, you can't have mac and cheese every day, Christina. Sorry.
I'm Wyeth McKinley. I'm a flight controller and a crew instructor for Artemis II. We're here at the Space Vehicle Mock-Up Facility at Johnson Space Center. We're inside the Orion mock-up where we perform crew training for the Artemis II mission. On the Orion vehicle, crew is able to heat up their food using our briefcase-style food warmer. The food is held in contact with the central heater plate by these springs so they can warm up and they can have a delicious meal. Much of the food and drink that's on Orion is rehydratable. And so crew at our potable water dispenser will fill up their food and drink, and then at that point, you go ahead and pop it into your food warmer.
I'm kind of envisioning there's maybe one person putting the stuff in and out, kind of tossing it out to everyone as it's done. Or maybe if we're not scheduled together, you're just on your own over there, popping some things in. Or maybe just in your 2 minutes of free time between things, you're kind of getting it ready so it has time to warm up. We'll see.
eating together really resonates with me. I think it's just a human thing to break bread together and to enjoy that necessary thing you have to do, the thing you should be grateful for. And so doing that as a group, as a family, has always been meaningful for me.
Absolutely. It represents togetherness and something a little out of the ordinary. You don't necessarily get to have those meals with everybody in your life, but if you are sharing a meal, especially if you're sharing breakfast, lunch, and dinner with a group of people, that means something. It's like a camping trip.
This is Artemis Mission Control, just a little inside look at some of the food flying aboard the Orion spacecraft with the crew. Today for lunch, the crew has a variety of options. Some of the things they'll be enjoying include beef stew, smoked turkey, chicken with peanut sauce, roasted turkey. They have cheese tortellini, butternut squash, cauliflower and cheese, and of course a fruit salad in there too. The motion you see of Orion on your screen is due to the exercise from NASA astronaut and Artemis II Commander Reed Wiseman. He continues to use the flywheel device inside the spacecraft. Again, we have each of the astronauts timelined to exercise for 30 minutes each day. Elsewhere in the cabin, Christina is working with the ECG device. As we discussed, the crew are performing checkouts of some of their medical equipment today. This is the electrocardiogram device checkout. This is, of course, with the crew being the first humans to fly aboard Orion, the first opportunity that all systems and teams have to check out their devices and hardware with humans on the spacecraft. Everything we do on this mission informs our plans for future missions around the moon.
All right, I got to remember to goose the Artemis II live views. This is an interesting exercise indicator. So we may see when that stops. That may be when whoever is using the resistive exercise device stops. All right, so I'll duck in a couple of more of these budget notes because this is more specific to Artemis. And what's interesting is that we can see where they're proposing the end of government assistance, if you would like to call it that, for Orion SLS and Exploration Ground Systems. So the absolute end would be, was that fiscal year 2031? 2031, I'm sorry. The sort of the anomaly with the SLS, these are the out years. So fiscal year 28, 29, 30, 31, those are covered by the money. Those are covered for, I believe, an additional 2 years for fiscal year 2028 and 2029 by the Big Beautiful Bill funding that's already passed. I'm not sure if there is any funding for SLS in fiscal year 30, but it does say they will be allowed to the contractors will be allowed to offer a commercial version of the vehicle. So that's probably let me switch back over here and make sure that's probably enough for today, because this is gonna, even if there's not a lot of attention on it, even if there's not a lot of attention on it over the next week and change. I know that the media will certainly come back to it in a week. If not, I actually would be somewhat surprised if Mr. Isaacman is available for questions. He will get asked eventually. That was noted during this past the mission status briefing / news conference about a couple of hours ago. So the optical communication system, there's only one ground station, as JC's saying. It's the Goldstone ground station in California, and so whereas the Deep Space Network has 3 locations around the world, so also Goldstone, Canberra I believe it's in Australia, and then there's one, I believe, in Madrid. So that gives you more or less continuous coverage. So that's the reason. So and the optical communication system this is a development test of the system. I don't know whether so I think we will probably ask more questions about it as we go. It's just that I asked a couple of flight controllers and a few people here back in September about this, a few people here in Houston. They seemed relatively confident in the equipment itself, because it's flown on other spacecraft. And so they weren't, but probably what's going to have to happen if this system's going to be put into
This is Artemis
use.
Mission Control. Again, the movement you see on your screen is due to Commander Reed Wiseman exercising inside the Orion spacecraft. That's a view from a solar array wing camera looking at the European service module, that large thruster in the middle, the OMS engine, the orbital maneuvering services engine. We were expecting to have an outbound trajectory correction burn today at 5:49 p.m. Central Time. However, that burn was deemed unnecessary due to our precise trajectory thanks to the trans-lunar injection burn. Earlier this morning, during the daily planning conference, Wiseman called down his thanks to the FIDOs, the Flight Dynamics Officers, for their excellence in that burn. Once he's complete with exercise, Wiseman is also timelined to work on his National Geographic filming. Again, we selected National Geographic through a competitive selection process to help us document and tell the story of the Artemis II mission. The crew members have time throughout the day scheduled to help capture those items, and a shot list provided by National Geographic with everything from exercise to family life, bedtime preparations, what it's like to live in space. They'll also explore the medical kit, which we've discussed today, and take plenty of photos, including just some memories of their time aboard Orion.
So just quickly to finish the thought on the optical communication system, they really will need to have sort of full globe coverage, similar to the Deep Space Network, for this to work effectively. It may, I think that's going to be the question. Is it's useful, but how useful is it if you only have the one ground station? Let me see if I can quickly go back. So Jay Pierce was asking about what was that? Was that the Earth or the Moon? If you're referring to the camera that was facing forward for a while, that was the Moon. But let me see if let me go back. I think it was before the. Was it before this one? Because this is facing forward. So this is what. This is like 3 hours ago, but I'm not sure if that's what you're referring to or not. But that's they said that's the Moon. So I'll just go back. Oops! Now I need to go live catch up. And so they can't. No, they might be able to do a shot of the Moon. But they're choosing to go with this view. This is just it's just a different It's different because the accommodations are different, so to speak. So it is not as, I think I showed a picture, but they just have flat tables out in the middle of a lobby area to do that. And so I guess because I'm old school, I prefer to have it's not a broadcast studio, but it's just I prefer to have many computer screens up, and I can there's a division of computer labor between between a streaming box and a box for looking up things and a box for control monitoring the chat, et cetera, et cetera. So when I was here 15 years ago, there was, and again it may have just been a coincidence, but there weren't that many people at Johnson Space Center covering it all day, and so I was able to bring some of that equipment into a room where I was able to set up, and I had access to electrical outlets. I had access to I did not have access I did not have access to Wi-Fi necessarily, but I was. Back then, there was no expectation of being able to do something like this. And so this mobile hotspot that I'm using it's adequate for about a 480p live stream. It's a good question. I think it's a choice in terms of if you put up a lot of engineering numbers. Actually, that's not a horrible thing. Let me see if let me grab a few pictures from the. I have a couple of laptops, and then I also I brought another little mini PC box, but it's basically headless, and it's just to do some additional. So like I can record some of the NASA streams here and archive that here, but then again, I also have computers that are still running at home, but it's for instance, one of the you can remote into computers, except it sounds like one of them crashed, and so all I have is I don't have somebody there who's a computer tech, and so they but they can sort of tell me, no, it looks like it's not on. And it's like, one morning I woke up and it just wasn't responding. So but I do have a couple of computers here that I can use, and rather than I have not had a lot of success over the years, and also just prefer not to try and run everything on one box. The water that they, for the most part, the water the water deluge it protects against acoustic energy, so it's sound suppression, which also it also essentially muffles ignition overpressures, because these are basically the difference between a solid rocket booster ignition and a bomb going off in terms of what the pressure goes, from 1 atmosphere to whatever that is coming out of the exit cone.
This is a live view
like a
of
bomb
the
going
Orion
off.
spacecraft, and
So the water helps to
we
dampen
were seeing
that.
some motion due to Commander Reed Wiseman exercising on the spacecraft. We have seen that cease for the time being, so we may be anticipating a call that is completed.
One of the interesting things is, of course, they have
Here in Mission Control Houston, the Orbit 1 team is on console monitoring all systems aboard Orion. It's been a relatively quiet day here in Mission Control Houston due to the cancellation of that outbound trajectory 1 burn. Just decidedly not needed due to our already precise trajectory, thanks to the trans-lunar injection burn.
They put up the picture of Earth that was essentially, I guess, backlit by moonshine. So I think if you go in the EXIF data, you can probably see what the exposure time was, but you can see it was much easier to see the star field around Earth in looking at it on a big screen. When I was looking at it here on the laptop, I've got there's some dust on the screen and so on, but I could see some stars, but when they projected it on a bigger screen, you could see a star field basically around the Earth. Yeah, I think there's if the moon base and the high launch cadence come about, and it's more likely that that's going to come from a commercial from dual commercial providers, assuming. I guess the question there is, again, when will that commercial capability exist? It does not exist today, and when the lunar landers are when they demonstrate the lunar landers on Artemis now 4, they'll have the commercial lunar landers, but they won't have the commercial versions of this Orion and SLS system. So the commercial lunar transportation systems are going to have to do their own Artemis II at some point. And so the question, right now we have a lot of questions about the progress of those 2 commercial lunar landers. We really don't have any insight into their schedules and their development paths right now. We know the high level milestones, but we don't know how late they're going to be. And so it's at least reasonable to assume that the commercial lunar transportation systems are going to be later than they're projecting here. So fiscal year 2031 would start on October 1st, 2030. That's 4.5 years from now. It seems like a long time, but they have a lot of work. it sounds like, based on the way that they're talking about Artemis IV, that it's going to be a challenge for SpaceX and Blue Origin to demonstrate their lunar lander capability in 2028, and that's half that time right there. Then they will have to crew rate. They'll have to crew rate Starship and whatever. It doesn't necessarily have to be a capsule, and obviously Starship's not a capsule, but it would need to be the function, a function similar to Orion, and again in the case of Starship has more of the launch to orbit and deorbit reentry and landing concept like Shuttle. Not completely, because again, Shuttle did not do that. It doesn't do that flip, and doesn't do the flip and catch. It landed like a conventional lifting body. But the big question there is going to be whether those systems are available by the end of 2030. And then the question from a budget standpoint, for Congress will be, what's more important, being cost effective or having a capability gap in that case? And in the past, when Congress has gone that way and retired one system and gone and moved to another one, they have chosen to wait for the new system to come online, and the old system they pick a date for the retirement for the old system and pretty much hold to it. So I mean, like with the space shuttle, the retirement date was set as 2010, and so I mean the last flight was in 2011, but that was, give or take a year. There might be a little bit of that same plus or minus a year. So one of those ideas of having a bridge capability, that's expensive, and it doesn't, who knows if Congress is going to be willing to do that. So we'll see. We won't. It is probably literally going to be something we see rather than hear in terms of what people say. It's just going to be in their budget, I think, because the Congress is controlled by the same party as the president, and so the big picture, the big P politics is, you don't criticize the head of your own party. So I would not expect there to be a lot of criticism. It's just they will either do the same thing they did last year, or again, maybe we will see. Again, we just saw Mr. Isaacman just changed Congress's mind about the SLS upgrades, and so again, maybe he can persuade them to that the science budget is okay at that level. We will see.
That call from NASA astronaut and mission specialist for the Artemis II mission, Christina Cook. She is conducting a checkout of the ECG device. That is an electrocardiogram device that is aboard Orion that requires her to use an app on the medical tablet. She's running through some troubleshooting with teams here on the ground, but this does call for the crew to take an ECG reading as they test out all of the systems and the tools they have on this flight.
I mean, I think they said. I think there's an opportunity. There's an eclipse opportunity. I think they said it was on the same day as the lunar flyby. I don't know if it's during the lunar flyby. But again, it would be interesting to get a picture of the sun with a star field. And if it was, well, yeah, and it would be the the moon would be interesting to get the star field and the eclipsed sun and the Earth in a shot. I wonder if that's possible. But there were 2 full disc pictures that were released, and hopefully there will be more. Well, actually, again, the opportunity to get a picture like that, it was relatively brief. They're so far away from Earth now that the Earth is they can probably zoom in on it, but
As we continue to monitor the Artemis II mission, now mission elapsed time of 1 day, 23 hours, 8 minutes. The Orion spacecraft is now 116,700 miles away from Earth. This mission is built by people and companies in all 50 states and with international partners. So with Artemis II flying, this is a testament to everyone's hard work and dedication. Let's learn a little bit more about them.
What we're doing here is a collaborative effort of hundreds of thousands of people.
This is about the parts, the hardware, the software, the services, all coming together to make that mission possible.
My dream for this space program is that we would not just push the boundaries, but that we push them together.
And liftoff of Artemis I. We rise together back to the moon and beyond.
It takes a team to do great things. And Artemis has an incredible team.
We have international partners. We have commercial partners and industry partners.
It takes unity to accomplish great things, and that's what this mission's all about.
We're not sending our money to the moon and lighting it on fire. We're putting that money right back into the economy in ways that benefit everybody. So every dollar that comes out of the Treasury that goes to support this mission goes back into the Treasury 3 times. What is very important to me is that we do it the right way, and that we do it with our values, that our industries grow, that our communities grow, that our families are healthy and safe and have amazing things to work on. Then we're going to build machines to go even further onto Mars.
That is our generation, the Artemis generation, that defines the starting point of our exploration future.
I just want to say thank you to all of the hands that have touched a part of this program and the hearts that have moved everyone to this goal, because we're going to the moon and we're going beyond.
One team.
One team.
One team.
One dream.
Y'all to exercise right until midday meal.
My apologies, Victor. We're checking. Integrity, Victor, you can go exercise all the way up to midday meal.
Copy, I'm getting started. Thank you.
No problem.
There was a I guess flight test objective version of exercise that was performed yesterday before the trans-lunar injection burn, but I think this is the first day that the crew is not so busy that probably all 4 of them are able to get some get some of this type of resistive exercise. There may be, it'll depend on how busy they get. So I'd have to go look at if we go look at the
This is Mission Control
timeline.
Houston, specifically the Artemis Flight Control Room. NASA astronaut and pilot of the Artemis II mission, Victor Glover, calling down to report he is hoping to get started soon on his scheduled exercise for the day. And since it's a little late, he's hoping to continue that until the midday meal. Now, we were expecting the outbound trajectory correction burn during that time. However, that burn has been canceled as we did not need it. We are on a perfect trajectory toward the moon.
Houston, integrity on 1 for HHP.
We're with you.
Hey, Chris. Victor's about to start exercise, but he's encouraging video downlink, so if you want to come on the HHP, I'll start the stream.
Thanks, Reed. We would absolutely love that, and thanks, Victor, for his willingness to let that happen. Reed, I do have an additional comment for you and the rest of the crew about a possible opportunistic photography and science opportunity over your midday meal. There's a period where we're going to have Earth viewing followed by moon viewing. You can reference the Orion attitude band in Optimus. It's kind of right in the center of your midday meal. And if you'd like to do any photography, we're recommending deploying and using the camera shroud over window 2 to reduce glare.
Okay, we love those little opportunities. Thanks for sharing them. Keep them coming.
Commander Reed Wiseman calling down to the ground. That is Capcom Chris Birch in the center of your screen responding to him. Capcom stands for Capsule Communicator, the one person communicating with the crew. Wiseman reporting that they expect to be able to turn on the camera inside the cabin soon, so we look forward to gaining those views of the crew. And Birch sharing
Houston, integrity for ECG.
Go ahead, Christina. How's the troubleshooting going?
Hey, Chris. We are connected and charging on the little tablet. However, no joy getting a signal on myself nor Jeremy. 2 things I can think of to try. One would be to let it continue to charge. It did just reach 20%. I checked, and it does not seem to be in any battery saver mode. In fact, it says battery saver unavailable. I also checked the Bluetooth devices. The ECG is showing up as a device. However, it is giving me the option to connect in the Bluetooth area, and nothing happens when I do it. It does seem to be finding the device when I'm in the app. So the other thought I could try would be to forget and reconnect the device.
Christina, that is an excellent idea. Good troubleshooting so far. Yes, we definitely want you to try the forget the device and then try and reconnect. And then another piece of data that might be useful for us is whether you see a battery symbol at the top of the medical tablet right-hand corner.
Do you mean within the app or just in the screens of the tablet?
Good clarification, within the app.
Okay, within the app, when the screen instructing to touch the electrodes to start is up, I do have a battery icon in the upper right. However, it is gray with a question mark inside.
Okay, Christina, thanks. Yeah, that just gives us that confirmation that it's not connected to the ECG. Let's go ahead and continue with that Bluetooth troubleshooting steps for getting and reconnecting.
Let me see if I can duck this in. I'm not sure I can. There was a question earlier about the Halo module on the moon base. That's something that's going to take a while, I think, to understand whether that's even possible and whether they're interested in doing that.
You're getting a live view inside the Orion spacecraft during some general daily activities that the crew is conducting. You heard communications with Christina Hansen. Christina calling down to Chris Birch here, our Capcom in Mission Control Houston. She continues to troubleshoot the ECG device that they are testing out. In the foreground, in the blue shirt, Commander Reed Wiseman, and next to him in the black shirt, Canadian Space Agency astronaut and mission specialist Jeremy Hansen. In the background, you're getting a look at NASA astronaut Victor Glover, pilot for the Artemis II mission, preparing to exercise. And what he is using is the flywheel device. We've discussed this a few times. This is
Houston, integrity for ECG. No joy seeing the device in the list of available devices when I attempt to repair it after doing the Bluetooth forget.
Okay, Christina, unfortunately, we are out of ideas at the moment. We're going to do some more thinking. We really appreciate all of your troubleshooting steps and actions you've taken. Great data for us, but we'll move on from this activity for the day. Thank you.
Copy all. I will keep the medical tablet charging and restow everything. Thanks for the help.
Copy all.
Again, those calls from Christina down to the ground as she troubleshoots that ECG device, the BME, or biomedical engineer, here in Mission Control Houston, working with their teams to continue developing procedures to help the crew troubleshoot. Back inside Orion, Victor Glover is in his timelined exercise for the day. On the flywheel device, This is a small device installed directly below the side hatch, so if you look above where his feet are, that is the side hatch of Orion. The flywheel is a cable-based device, so you can use it for either aerobic exercises like rowing or resistance workouts like squats and deadlifts, and today Glover is timelined to do resistive workouts. It can max out at 400 pounds of resistance. This view really gives a great look inside Orion and at the size and space available. Again, you're looking at 330 cubic feet habitable volume, so about the size of 2 minivans inside. The crew obviously did not launch in Orion in this configuration. They have since been able to stow quite a lot of the hardware that was used during the launch portion. That gives them more space to move about the cabin.
Yeah, it is interesting how the size of the Orion crew compartment. But that's one of those things that's, again, that you don't, I don't know if it comes to mind right away, but when they say Orion has to support 4 crew for 21 days, that means you have to take things like, you have to take enough water, you have to take enough food for 21 days. So a lot of they talk about habitable volume, and then they talk about pressurized volume. And so it's kind of like your house. It's like how much of the area inside your house is, like how much of your garage is full of stuff. How much of your rooms, not just your closets, are full of stuff. I know for me, there's a lot more pressurized volume that's taken up by storage that's not really in storage than there should be. But this is interesting too, because it gives you an idea of, again, we were talking about how they're stowing their launch and entry suits, and I believe that's up against the Eclipse wall, so to speak, and so I believe that the public affairs folks have said that and you can see it there, the Victor is in that part of the device is set up on the hatch side of the crew compartment. Up. Let's see if I can. I should do that since it's not likely they're not going to cut away from this. I wonder if this was in the flight plan to sort of quote unquote come on board. But I know there's been a lot of we saw it in chat yesterday, and I think definitely yesterday. It's like we hadn't seen a lot of the crew. They've been really busy the first 2 flight days. I imagine that public affairs, the public affairs folks that are not on console and mission control have heard some questions about that themselves. But what I'm going to go take a snapshot from the real-time visualizer. What it looks like they've stowed, because we can't see them, are the seats. I think the back supports for the pilot seats for the commander and the pilot are probably still there. But the foot pans and the legs are probably stowed in lockers in the floor, essentially here.
As pilot Victor Glover continues exercising using the flywheel device, this is something that we learned early on during our spaceflight history would be critical for astronauts living and working in space for longer periods of time. On the International Space Station, astronauts are timelined to work out for approximately 2 hours a day to help maintain their bone and muscle health. On Orion, they're timelined to exercise for 30 minutes a day. Not only does this exercise help benefit the crew members and keep them strong, but it also helps inform how we treat things like osteoporosis on Earth. This is Artemis Mission Control, the spacecraft traveling 3,400 miles per hour, now over 118,000 miles away from Earth and 148,000 miles away from the Moon. You can track those stats for yourself anytime at nasa.gov/trackartemis. We also got some beautiful images from the crew this morning. Their first look back at Earth after the trans-lunar injection burn. You can also see those images as well as the ones we intend to release as they come down on NASA's social media accounts at NASA and at NASA Artemis. In this live view from inside the Orion capsule, you can see Canadian Space Agency astronaut Jeremy Hansen there in the black t-shirt. Looks like he is unpacking some of the crew's meals ahead of their midday meal coming up. We talked through some of their lunch options for today: beef stew, roasted turkey, cauliflower and cheese, cherry blueberry cobbler, butternut squash, roasted turkey again, cheese tortellini, vanilla pudding, and the most appetizing, chocolate pudding cake. And if you're a sauce fan like me, you'll like to know there is maple syrup, chocolate spread, peanut butter, hot sauce, spicy mustard, strawberry jam, honey, cinnamon, and almond butter, all flying around the moon as well. If you look closely at Canadian space astronaut Jeremy Hansen, it appears that if he is wearing 2 watches, but one of those is Archer. Artemis II astronauts wear wristband devices that continuously monitor their movement and their sleep throughout the mission. This data is going to be used for real-time health monitoring and safety assessments. And what they've completed pre-flight and will complete in post-flight evaluations help us get deeper insights into their cognition and behavior, their teamwork, of course, and their sleep quality in the deep space environment and inside Orion. Archer stands for Artemis Research for Crew Health and Readiness. And everything we learn from this test flight helps us prepare for future mission planning and crew support systems.
Hey everyone, I'm back, at least audio-wise. I figured it was a good time while we were watching the crew work and the public affairs officers were running some features. It's talking about the crew and talking about the work that they're doing inside to get a couple of things done, check in at home, so on and so forth. So,
use and integrity exercise complete. Thank you.
Thanks, integrity. We copy.
I took a quick look around some of the reporters that I'll check on from day to day to see what they're talking about, and it's probably about 50-50 between half the reporters are talking about Artemis II and half of the reporters are talking about the budget. So it's getting they're both getting some attention today. But I think attention's going to swing back to this because the lunar flyby is on Monday. So I think as we get closer to that, the attention will shift back to Artemis II. And then there may be a little bit of it. It depends on. I'm not sure there's going to be a lot of talk. Probably people will be digesting the budget for the next week and longer. And so in the middle of that, we'll be watching Artemis II. But I think there were some questions, at least one question today in the press conference about the noticeable change in pace from the first 2 days to today's.
As you heard the call from pilot Victor Glover, he has completed exercise and was very kind enough to give us a view inside the cabin while he was exercising. We previously have seen the views from outside the cabin while the crew is exercising and how that imparts movement on the spacecraft. Now the crew is getting into their midday meal. Again, we were expecting to have a burn in 10 minutes, so if you are tuned in and looking for the outbound trajectory correction burn, that has been canceled for today. It was deemed unnecessary because our targeting was so accurate for the trans-lunar injection burn. Again, that trans-lunar injection burn came last night at 6:49 p.m. Central Time, 5 minutes and 50 seconds, using the orbital maneuvering systems engine on the Orion spacecraft. And when you hear the crew call down and discuss their PCDs, a portable computing device, it's exactly what you see Hansen and Glover using right now, those tablets that allow them to track what they've been up to in the spacecraft, monitor their timelines, and communicate through email.
We'll have to see if there are long enough breaks here, but in between when the crew's talking and public affairs officer is talking, I'm trying not to step on those as much as I can. But if anybody has any questions about Artemis II or Artemis in general, you feel free to throw those in chat, and I can either answer them this way or I can try and answer them in chat while we're listening to communications between the crew and the ground, or I guess the channel is called Orion to Earth.
Houston Integrity, AGA readings when ready.
All right, we'll take them. CO2 1.0, O2 20.1, temperature 75.7, cabin pressure 14.2 psi. Copy all, and we believe we copied CO2 1.0. Just want to confirm.
One decimal zero, 1.0. That's correct.
Okay, thank you.
You're welcome. And a question, do you guys always want these called down, or is a crew note enough?
And our preference is call down. Just helps us keep in sync with you guys real time.
Copy.
With the completion of this block of exercise for today, Glover calling down readings from the AGA, the Anomaly Gas Analyzer. Those readings are requested before and after exercise, so they leave the device on throughout the time period that they are using that flywheel device. This helps teams on the ground monitor what the levels in the cabin are for the various molecules that Glover called out, and those are reported in parts per million. And we have just passed 2 days mission elapsed time, 2 days since the launch of Orion, the Space Launch System spacecraft from Kennedy Space Center in Florida, a very smooth ride uphill. We are now 3 days and 19 minutes away from the opening of our lunar flyby, targeted for flight day 6, when the crew will fly around the moon, the first time in over 50 years for humans to do so.
So they're changing positions here. That's Jeremy Hansen on the left. Jeremy Hansen here, Victor Glover here, Christina Cook. And then we could see, I think you can see that light blue. That's Commander E. Wiseman. It looked like he was opening the door to the toilet, the very popular toilet. There he is. A little while ago. And he is over in that area. That's the compartment where the toilet is right next to the side hatch, which is this sort of dark area here. And that's where the resistive device was set up, or that the feet, where your feet go, in the resistive device. We saw Victor Glover exercising earlier. The crew, of course, has a detailed timeline. We have not heard of anything at all with the solar arrays. So the crew's reported to be well, and they certainly look well. Yeah, I don't know where that report. I think, unfortunately, sometimes, especially on YouTube, you will see things. You will see things that are like I've been tricked a couple of times. I'm like, oh man, it's like within 1 second you're like, oh well. Most of the time, I'll look at a headline, or the title of a YouTube video, and if it's sometimes it's a crazy headline and it's true, but a lot of times you look at them and you go, well, wait, let me check. I think the last one I saw had to do with, again, I'm American, so American football here is very popular, and so there was a video, and then I'm not even sure if it was really a video. It was probably, again, AI slop, but still, the title talked about a trade of a particular player, and I'm like, oh wow, that happened. So before I clicked on it, I'm like, wait a minute, let me go check ESPN, or let me go check somebody and see if they're reporting on it, because if this trade happened, if this was real, there'd be a lot of talk about it. So not quite the same magnitude for an issue with the solar array panel on an Orion Artemis mission, but if there was an issue with the solar array, somebody would have said something. And so we have not heard of any issues with the solar arrays. The spacecraft is healthy. The crew seems healthy. The crew has regular private conference time that they can have. They got a chance to talk to their families today, I believe. But they also have time carved out of the timeline to talk to, if they need to talk to a medical doctor. They have these things called private medical conferences, and then there was one of those acronyms on the timeline that somebody here pointed out, and I was able to ask Judd Freeling. I hope that's his last name. About that acronym on the timeline at the end of the press conference, and I think he said it's PPC, which stands for private. Is it psychologist or private psychology conference? It's mental health. So again, they have the opportunity to speak to a medical doctor, to a psychologist if they want. The crew has access to that, the same types of health care that we have here. Maybe not at a little bit. It's being paid for by the government in that case.
2 days and 14 minutes mission elapsed time for the first flight of humans aboard Orion, and I am joined here by Paul Boehm, Orion Crew Support and Thermal Systems Manager. Thank you for joining us, Paul.
Oh, thank you very much for having me, Leah. Appreciate it.
Yeah, absolutely. Well, tell us a little bit about your role. You just came from the Orion mission evaluation room. Is that right?
Yeah, actually, I just did. I was just checking our systems to see how things were going, and I am really pleased. So my role is I manage the hardware related to crew and all the crew systems on the vehicle, the ECLA system, the thermal systems, the suits, the flight crew equipment that are on the vehicle, and so been doing that for almost 14 years now.
Wow, that's impressive. And when we're talking about the ECLA system, that stands for Environmental Control and Life Support System. So what all makes up ECLS?
ECLS, yes. The biggest thing everybody thinks about for ECLS is the life support system, the pressurization system, the air revitalization system that we have, and then the other parts of it that are also part of it is the thermal aspect of it, where we're cooling the air to be able to keep the crew temperature down exactly where they want it to be comfortable in the cabin, and so that is also part of our system as well.
Yeah, we heard them make some calls a couple days ago about being a little chilly, and your team is the one that works on making sure they're comfortable?
Yes, we've been working that the last couple of days, trying some adjustments. It's one of the things I will stress with the new vehicle. We are learning every single day that we're flying this vehicle right now, especially with the crew in it. We flew Artemis I. We learned some things about the systems there, but now we have the crew involved, which adds a whole new dynamic to the vehicle, and that is what is really what we're looking at today, and learning how to interact with the crew and adjust things as we need to make the crew comfortable.
Yeah, that's fantastic. And you also work with the food systems a little bit as well. So they're actually getting ready for a midday meal. We've been fortunate enough to have in-cabin views for some of today, and we saw them getting out some of their food. So can you tell us about the food warmer?
Yeah, the food system is, the crew is, a lot of the food that we use is very similar to what they fly on ISS. It's the rehydratable food. What we use on Orion, we have what we call a food warmer. It's about a little suitcase-sized device, and our biggest challenge is mass and volume on Orion going to the moon. And so we had to reduce the size of a galley. We would love to fly a galley, but we just can't because of the mass and volume challenge. So we have a suitcase that basically the crew inserts their food into the suitcase. It's a warming plate and heats it up to about 155 degrees.
Oh my goodness, that's much warmer than I expected you to say. That's really impressive.
It's what they use for doing the hot drinks, the warming up the food that needs to be warmed up so that it tastes better when it's warmer. So they can put about 12 packages in there to be able to heat up those and be able to have some hot food during the flight.
I'm impressed. I used to be a taste tester here, and so I always enjoyed trying the food. I found it to be really good, and so
it is amazing what they can do.
Yes, it really is. So tell us more about the Eclipse system and how it's performed so far now, 3 days in.
Yeah, I'll be honest, I am extremely excited how it's performing right now because it is actually better than our predictions, which is really great. The carbon dioxide removal system that we are flying for the first time on a human spacecraft, relying on it, this particular system has been outperforming what we thought it was going to do. It's been awesome. So really low levels, and the crew's so far been pretty complimentary of it.
That's incredible news. So you were talking a little bit about, the temperature and how this is the first flight with crew, and so everything you're doing is learning. So what is your team hoping to learn on this mission?
So the biggest thing we're doing, number one right now, as I mentioned earlier, was because it is a flight test and it's the first time we're doing it, we're learning how to tweak things, we have heaters and we have the systems like the CO2 system I mentioned earlier. We're learning how to balance all those things as we work with the crew, because each crew member is different metabolically. We have different met rates that the crews have as they're doing different exercises, like you saw them exercising earlier today, versus when you're doing a meal, you're pretty calm and therefore you have a very low metabolic rate. So those variables really change how we interact with the crew, with our system. And so that's really what we're learning today, is how our system interacts with the human.
Integrity. We need a few minutes. We'll call you when it's a good time.
Copy, sounds good. We'll wait for your call.
That call from the crew about performing a wastewater dump. We actually had great views earlier from inside the cabin while they did so. It was fascinating. Talking about, preparing for the future, but we've also had similar hardware on the space station for the past 25 years. So what are some differences in the hardware that we have now on Orion and versus what we have on the International Space Station?
Yeah, our biggest difference between Orion, because we are a deep space vehicle, you have that very long return, and there's no coming back until when you do that trans-lunar injection burn that we did yesterday. And so it's going to be many days before we can actually get back. So when we designed Orion, we really looked at the ecosystem to try to figure out how can we make it simpler. And then some of the systems that we have, as I mentioned, the CO2 removal system that we have, we needed a regenerable system such that you weren't flying consumables that you had to use up every day and replace. That's a lot of things. I think I calculated one time it's about 143 basketballs worth of lithium hydroxide canisters we would need to do a 21-day mission with Orion versus our current system, which takes about 16, the volume about 16 basketballs to be able to go do that. And so it's a regenerable system. It essentially removes the carbon dioxide from the cabin air, dumps it overboard, and those items are recyclable every time you expose them to vacuum. They regenerate, and now you can expose it back to the cabin air again and remove more CO2. So it's those regenerable type systems. We flew some test examples of this on ISS to see how that went, but this is the first time we're actually flying with this type of system on a human spacecraft and completely relying on it.
Wow, amazing. And we've also heard some calls about the anomaly gas analyzer and taking those readings and the calls down from the crew about what they have gas-wise in the cabin. So how does your team take that data and interpret it?
So the biggest thing we have is certain limits on CO2 levels that we try to maintain without getting too specific, but I will. It's 4 millimeters of mercury is the level that we rely on. And basically we use those AGA measurements to basically bounce against that level that we're at. And so I believe, if I remember correctly, it's about 0.4 millimeters here on the ground that we're normally breathing. And so we try to stay as low as possible with carbon dioxide in the cabin. So, and the readings that we're seeing right now are actually kind of phenomenal for a human spacecraft. So it's great.
Wow, that is great. Well, congratulations to you and your team on a great mission so far, and we will be keeping an eye on everything as we move forward. But Paul, thank you again for joining us here.
Oh, thank you very much for having me. It's been a great flight so far.
Houston Integrity, you are go for Blizzard.
Copy, go for Blizzard. Christina, while I've got you and the crew, I have some information regarding a replan for the afternoon. Shouldn't require too much back and forth, but let me know. First is, we don't have any other vehicle statuses from what we've already told you. So unless you guys have questions for us, we were going to go ahead and cancel the Flight Director Crew Conference that's in 10 minutes. We also are going to do a little bit of a replan with you guys managing the afternoon post-midday meal, basically after the PAO event. We'd like to give you a bit more time for exercise and sliding back that S-band SAT mode DFTO a little bit. And then exercise after that. This means that you'll have to manage some of that pre-lunar flyby cabin config and other activities just amongst yourselves. But this should allow us to get in all exercise and have enough time post-PAO event for that S-band SAT mode DFTO. The DSN EMERCOM DFTO needs to stay where it is because there's some vehicle maneuvers that have to happen with that.
Hey, Chris, let me just make sure. Are you saying we can defer the S-band SAT mode DFTO, but do the DSN EMERCOM on time? And Chris, if it helps you, Victor and I have both exercised, so he is more than happy to do the S-band SAT mode DFTO on time.
Thanks, Reed. Just talking down here with the team to make sure I got the right words to give you. We'd like that S-band SAT mode DFTO to slide 30 minutes to the right for some ground config. But then the EMERCOM DFTO will stay where it is.
Okay, that sounds good. Ike will be ready 30 late for S-band SAT mode, but if you could also please give us a heads up when your commanding is done and you're ready for that activity, that would help us out.
Absolutely, Wilco. The other thing we want to remind you is that in your midday meal, we have about a 1 hour forward DSN LOS, but for most of that, we've got return. And kind of in the middle of your midday meal period, you'll notice there's, like I mentioned, this good Earth and Moon viewing positions. It's also roughly when you're going to pass close to the halfway point between the Earth and the Moon, and you can reference your altitude on the PFD for that midway point.
Yeah, crazy that we're seeing 105,205 miles, and it's still going up pretty quick. Thanks for all that, Chris.
Great. Thank you guys so much. Enjoy your lunch.
Those calls from Capcom capsule communicator Chris Birch, also a NASA astronaut here in Mission Control Houston, up to the crew aboard Orion, named Integrity. This view of Artemis Mission Control, the Orbit 1 team still on console. The crew was enjoying their midday meal. We do not have fresh foods flying on Artemis II. Orion does not have refrigeration or a late load capability prior to launch that we need for fresh foods. So we have shelf-stable foods aboard Orion and rehydratable foods that the crew is used to, having flown on the International Space Station. As we saw in the earlier video, the Artemis II crew had direct input into the food that they have available during the flight. They were able to sample and rate all of the foods on the menu, and their preferences were balanced with the nutritional requirements needed and what Orion can accommodate. Back with those live views of the Artemis II crew. We just spoke with Paul Boehm, Orion Crew Support and Thermal Systems Manager, telling us a little bit more about the food warmer on Orion. So if the crew needed to heat up any of the foods that they are eating today, they were able to do so with a approximately briefcase-sized food warmer to heat the meals as needed.
So there was somebody asking about that earlier about a microwave. So yeah, they don't have a microwave. Not sure that would play well with some of the systems on the spacecraft. And it's also pretty bulky. When I get a chance, I'll see if I can go in and adjust the moderator bot, the night bot, to adjust some of those thresholds. see if I can. Okay, so if I've got the right meal here, let's see. Yeah, that's about right. She was the public affairs officer was talking about how they just recently passed, and we just recently passed in the last half hour a mission elapsed time of 2 days, and so we're in that block of a meal. And then after that there would be the CPR demo, and then a PAO event. So that I assume will be similar to the ones yesterday. So those will be scheduled sessions, I guess. It's probably not the best way to put it, but scheduled interviews, if you want, with some of the bigger news organizations. And so yesterday, I think I forgot the third one, but somebody said ABC News. Was it ABC News? I think it was ABC News and Fox News. I may be missing or have one of those incorrect, but the organizations that have been around that long and are of that size. That would be in a couple of hours or so.
Integrity Houston, sorry to interrupt your lunch, but we have a commanding request prior to CPR demo during the forward LOS. Let me know when you're ready.
Go ahead, Chris.
All right, because you'll be starting the CPR demo activity while we're in that LOS, we would like you to first confirm we are in coast to default 4100, and then please put all 4 saws into Safe Harbor A, then start the CPR demo. I'll copy.
Okay, Chris, before starting CPR demo, we will verify coast default 4100, and we will command all 4 saws to Safe Harbor A.
Good read back. Thanks so much. Integrity courtesy call, not knowing your preference. We did have video of Victor, which we have stopped going out on our PAO stream.
We appreciate that, Chris. We were definitely good with it going out, but we also understand if you want to restrict, no problem either way.
Okay. Copy all. I will update our now growing crew preferences sheet. Thank you.
Back with views aboard Orion as the crew continues their midday meal. NASA astronaut Victor Glover having completed his exercise. Cleaning up in space. Obviously, we do not have showers aboard the Orion spacecraft.
Yeah, I guess this would be like a sponge bath, or not sure what else it's called. That's what we used to call it when you couldn't. Yeah, there's no shower. And this is they've talked about how this is, in some respects, this is like a 21-day camping trip. Except in this case, it's a 9-day. So the mission duration is a little bit more than 9 days. Possibly, Alan. Yeah, it's possible. I think Orion. There's not enough room on Orion. I would think. Whereas for Starship, yeah, there could very well be enough room for a shower or something more elaborate. I think Skylab had. I have to go look it up, but I think Skylab had like a sort of like a first iteration shower. It was big enough. I think it was a shower. So you can see they've got Victor's got another storage compartment, or no, maybe that's just the space between the seat backs. That might be what it is. So maybe that's not. It just looks a little different when there's nobody lying in them. I wonder if that was Victor. I wonder if that was the. I wonder if that was Victor going to the bathroom, so to speak, going into the bathroom. But somebody was asking earlier about how come things aren't floating around, and so of course they're velcroed down or they're restrained, and the problem is if you didn't do that, it would be very difficult to stay organized. The I would think the solar panels would be. I'm not sure there would be a lot of difference between the solar, how effective they are out at lunar distance versus, anywhere else, close to Earth. Because then they've gone back outside, but. And the thing is that Orion, there is going to be an eclipse period, so they will go into a shadow. And those are okay as long as they're less than 90 minutes. But I think, is that the moon? Actually, that could be Earth. They were just talking earlier about how they're getting close to the point where they're about halfway, halfway between. So actually that could just be sun. That could just be the effect from the sun. But they're getting distance-wise, they're almost equidistant from the Earth and the moon. It probably depends on the accelerations. So, the bigger the engine, the bigger the engine, the more of a kick it gives you. And so it's possible that if it's a more gradual thrust, then it wouldn't be quite as much of a push. And so, going back to the solar panels on the when Orion goes behind the moon, I'm not they aren't going to be in eclipse or in shadow that whole time. It might not even be at closest approach, because the closest approach to the moon is thousands of miles for Artemis I and for the old way of doing things. When they were passing.
This is Artemis Mission Control here at Johnson Space Center in Houston, Texas, getting a live look inside the Orion spacecraft. They are still...
Integrity, toilet will be available throughout the LOS.
The crew is timelined in their midday meal right now. Obviously, they have mostly finished eating, but the ground teams also let them know they should have some great views of the moon and the Earth outside of their windows, should they choose to take pictures at this time. As we saw earlier, there are also timelined wastewater dumps from Orion, and during that time, the crew is instructed to not use the toilet. So the crew is about to go into an LOS, loss of signal, while they're on the Deep Space Network, and the ground teams here were calling to let them know that there will be no wastewater dumps scheduled during that time, so they'll be able to use the toilet as they need.
I think I'm trying to remember what Lakeisha Hawkins said about the humidity levels in there. I want to say she said 25% sounded. I'm not sure that's. Well, it must have been, because it wouldn't be 80. I'm not sure if that was the temperature they were looking for, but they were talking about how they do need some humidity, and they don't want it to be, they were talking about they don't want it to be Arizona dry, but they also don't want it to be Houston humid either. So we must, there's Jeff Radigan. I guess we're not completely LOS here, but got to find a time to take a break every once in a while, even on the ground.
This view outside the Orion spacecraft, you can see those solar arrays positioning. And a reminder, you can keep up with where Orion is at any time by visiting nasa.gov/track-Artemis. Currently, the spacecraft is 122,500 miles away from Earth and 146,000 miles away from the moon. Up next on the Artemis II crew's timeline today will be the CPR demo. Ground teams have requested that as the crew conducts this demonstration with choking and CPR responses in the cabin, that they configure one of the cameras for recording. They'll be able to use the footage captured for this for future training use.
It might depend on how big an IMAX camera is. If they've got it down to a, I mean, and those are. I think it would just depend on how big those are. So you could kind of see there how Victor velcros down that digital camera. I mean, it's not strapped down, but that keeps it from. I think if you let another thing would again, it would just get lost in a blizzard. The thing is, so if you didn't secure it to something with the fans going, it wouldn't, or even without fans, you talk about things floating. If you came back 5 minutes later, you wouldn't know where it would be. There's a lot in terms of the numbers for, it's hard to tell if everybody's, there are different numbers, and it's hard to tell if everybody's using the same units. There's statute miles, there's nautical miles, and then of course there's kilometers, which is standard. But They did mention a number in the. They mention a max distance number. That the estimate is, the estimate continues to be refined, because they're going to be doing at least one correction burn, and that could certainly adjust the final distance by a mile or two. So. Or more, so. Well, I mean, I know National Geographic has. I don't know if we've seen the equipment on board, but it isn't so much. I mean, the bigger it is, the more it takes, more room it takes up, the less, it isn't just the mass of something. It's also the dimensions and how much volume it takes up. So if whomever can come up with a small lightweight device, like a GoPro or an iPhone, then so if you can do IMAX resolution, large format resolution on an iPhone, then that would be one way to do it, because those are relatively small, or at least small form factor, don't take up a lot of room. Well, it's possible, but I think that the issue is then again, they talked about how much volume they saved by using this regenerative carbon dioxide removal system versus lyo canisters. I forget how many I heard that stat a long time ago. How many basketballs worth of lyo canisters, or in terms of volume, it would take up to do that. All right, I saw that.
We are 2 days, 1 hour, 3 minutes into the flight of Artemis II, the first flight of crew aboard Orion. Spacecraft now 123,000 miles away from Earth. You're getting a live look inside the capsule as our 4 crew members, Reed Wiseman, Victor Glover, Jeremy Hansen, and Christina Cook, are wrapping up their midday meal, getting the opportunity to take photos out the window of Earth and the Moon. We are in an LOS period, loss of signal from the ground side. This was tracked and communicated to the crew. However, we do receive communications from the crew members. Obviously, we have their live video right now.
Whoops. Just catching up the stream here a little bit. Right when it. So I'll have to go look at, as I was saying before, it looks like, this is the first time that I've done, 6 hour, 10 hour long live streams. And I've been just using the moderator bot defaults for the most part. So I'll have to go and look and see. What their default limits are. Now, having said that, this mission's not that long, and so I don't expect to be doing a lot of 6 hour live streams. I wonder if they darkened that window to take some photography. There's a circular.
Inside Orion, you see they have dimmed the cabin lights. They have this option to allow them to get better views outside the window, so there aren't any reflections from that lighting onto the windows. Being that we are 123 miles away from Earth and that distance continuing to grow, we are 145,000 miles away from the Moon. And I think I previously said 123 miles from Earth. That's 123,000. So we are getting closer to that halfway point between the Earth and the Moon.
Yeah, there's a the structure has a window. There's a cone part of the structure.
We look forward to the opportunity to share some of these pictures that they are taking today, along with everything else during the mission. We did receive some beautiful images this morning from the crew as they departed Earth after the trans-lunar injection burn yesterday. You can follow NASA on social media at NASA or at NASA Artemis to see these pictures as we receive them.
I'm trying to remember if there are 4 windows on that part of the cone structure. Let me see if I can find that. Let me see if I can find that graphic. It's just the bare pressure vessel. I think actually, you know, I got to see that cone panel. When was that? 2017. So I mean, almost a decade ago, when it was just a cone panel. That the supplier. The manufacturer, the supplier, is out in the Los Angeles area. Let me find it. But I actually saw this hardware multiple times. So then I saw the pressure vessel when it had been completely welded, and I think it was the middle of 2018. That actually might be that's probably a more interesting picture. Let me see if I can, I don't know if I have it here or if I have it. Yeah, that works. Well, in theory it works. If I can. Right. So this is the exploration mission 2, and eventually became the Artemis II pressure vessel. So this is, I believe, 2018. So that's how long ago it was. So you can see the 4 windows in that. Again, this is the pressure vessel has the top hatch and tunnel, and then this is the cone. This cone structure is 3 panels, and the hatch is over here. And then there's a barrel, and there's a forward bulkhead and an aft bulkhead. And so those are the main windows here. You can, we're sort of side on to that one window, but there's, these 2 windows and then 2 outside of that. And then there are hatches in the, there's a hatch in the top and there's a hatch on the side. And they ingress and egress typically out of the side hatch, but you can egress out of the top hatch if you need to at the end of the mission. And then obviously when they start docking to other vehicles, that's the easiest way to transfer. Maybe the only default way to transfer between spacecraft. I'm going to move this out of the way while we're doing the display again. So by the time that, not sure exactly when that might be called out in some reference when they, I think it is called out in the timeline. That maybe that's not, I don't think that's the equidistant. I was thinking of sphere of influence, but I don't think that's when it's equidistant from the Earth and the Moon. It's still in the Earth sphere of influence at that point. Let's see if it's on here anywhere. At least the estimate. Because I was wondering if, by the time we wake up tomorrow, if they will have already passed the point where they're closer to the Moon than the Earth. but both of those hatches have a circular window in the middle. They're obviously different geometries, but
this is Artemis Mission Control.
They both have
Clearly,
windows.
what you have on your screen is a visualization. We are in a loss of signal with the Artemis II crew and the Orion spacecraft. This was a tracked LOS while we are on the Deep Space Network. We expect to regain communications shortly. In the meantime, the crew using some of their lunch break to photograph Earth and the moon outside of the cabin windows.
That's probably one of the constraints. So Kirk's asking, is it possible when they fly around the moon, they will be able to see Mars at all? If Mars is visible, the one of the problems is, we're just talking about the windows. This is not like going out in your backyard. And so if you set aside the light pollution that we have in a lot of the, densely populated areas, if you go out, so I went to school in San Diego, and so that has a lot of light pollution, so to speak. And so we would have to go, we went out east of the main area. You can get away from the light pollution. But one of those sides, if you had a full moon, that would wash out the sky too. But in terms of going out and looking for Mars, if you go out in your backyard, you have not a full sky view, but you have a very big sky view. Inside the spacecraft, they can't really, they can't stick their head out and look all the way around. So if Mars happened to be out the windows in a particular attitude, then yeah, they would be able to see it. So you might look for Venus right now or Jupiter. Those might be easier to see because of their apparent magnitude. But where are they in the sky? And the thing is there a window that happens to be pointing in the right direction? So if you think back to Apollo, they had a sextant. If they had to manually realign the platform, they would go or make make a platform, an adjustment to the platform alignment. They would go and find they had a sextant, they would go and point the sextant at it. But I don't know that they have equipment like that. So this isn't a live. The only thing live here are the numbers in the lower right. So this is just as it says in the upper left, it's a visualization of where Orion is relative to, and I'm not sure that that would be the apparent size of Earth at this point anyway. So I was trying to bring that site up earlier. Actually, maybe I will. So this, if we have time here before, let me see if I can do this before PAO comes back, to show you some of the displays in the flight control room. They don't use this, but again, different audiences. So, but I guess I was a little more partial to even this real-time display can be configured to show you. It doesn't show you a animated picture of the spacecraft and its attitude and other modes, but it does show you where the spacecraft is in the its overall trajectory to the moon. And it also shows you where the moon is, but they're not, objects may be smaller or larger than they appear in the mirror kind of thing. So I'm trying to grab a couple of pictures of. I think the information in these displays should be okay. Oops. So that I need to close this window and see if it'll come up. So yeah, this is the wide shot. So this is this is from the observation area, or what do they call it? Gallery, but these are the the different flight controller positions, and then the media in the that are taking pictures like I was. Let me see if I can move through these. There we go. I'm gonna need to go. So I think we got a brief glimpse of this display in the on NASA TV. I keep calling it NASA TV because that's what it used to be, but in these live streams. But so this is earlier today, but this is this is at least sort of distance and scale of distance, and then again a little bit of ground track, but you could see again this is about 10 hours ago now, but you could see at the time they're using. You could probably do the math, but again, as you see there, NMI nautical miles. So at least they're, well, I guess some people just don't like. Some people don't like the imperial units. So enough said. They're using nautical miles. It can be converted. So looks like they're getting their pictures back. Let me see if So these are just some of the displays. Again, from a situational awareness standpoint, this was okay. The problem is, I think then this is interesting for us, but then there'd be other people who would look at this and just be lost. And I think it's just, they're going to keep it simple. So like the visualization you see, they're going to keep it simple. And obviously, it's paid for by U.S. taxpayers. So we are still here. We are still miles instead of kilometers, amongst other things. And so it's tailored for that audience. But you can see these displays are more technically oriented. They're more about, how long is it until, what's the current time in GMT? What's the mission elapsed time? The big event, the flyby, then the sort of biggest event upcoming, the next biggest event today. And of course, so they were still, they were continuing to plan for that trajectory correction maneuver, and then decided, they went through the process and decided it wasn't necessary. And then you have over here, you have current time, mission elapsed time, and then sort of the next events coming up. And they did also have over here, they have some COM displays and current COM configs. So you've got, uplink, downlink, current DSN source, so to speak, which was Canberra. I think it used to be called Honeysuckle, but it's in Australia. But I think those displays would be, I guess you could say it would be nice if they could provide additional displays, but this is the one. And to be fair, if you go to the site, I think that I was trying to, do a screenshot of a more recent, of what the numbers are with a different visualization on that site. It's just the website had either crashed or was just oversubscribed. There were just too many people on it. I can try it again, but we'll see if it loads this time. Oops, that's not what it was. Okay, good. I remembered to stick it back on the... Well, let me make sure that is... Yeah, so that is live. Or at least that's what we're getting from the... That's what we're getting from the live stream.
This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. Mission elapsed time of 2 days, 1 hour, 26 minutes of the flight
still
of
having
Artemis
problems
II.
loading the website. Let me try it over here on this computer.
Our crew members aboard have wrapped up their midday meals. They are now moving into the CPR demo. This allows the crew to practice how they would practice CPR should they ever have the need aboard the Orion spacecraft. They will record this for the flight teams here on Earth to analyze and use as future training. You also just saw some movement on the camera. They were moving the solar array wings into the safe harbor position. This is what we do when we expect any movement inside the spacecraft, whether that be exercise or something like this CPR demo. We won't have inside views during the CPR demo.
Houston integrity in the blind. We are in 4100 coast default. 4 arrays are safe. Beginning the CPR demo now.
And if you heard that call from Commander Reed Wiseman, he says in the blind, not knowing whether we can hear them or not because we recently experienced a loss of signal or an LOS. Obviously, we did hear that call from the crew.
Yeah, so yeah, I saw Joker asking about the. I did finally see the FY 2027 request materials that were released, but it's busy enough. It's busy enough with. There's a lot of obviously. Artemis II is sort of the highest priority, but we're starting to see sort of visible increase in the Artemis 3 preparations, which would make sense since Artemis 2 has now launched. But it's like I knew that it was coming probably today, and then I completely forgot about it until I was in the auditorium at Johnson Space Center, and one of the other media there mentioned it. I'm like, oh yeah, I forgot. So, I mean, and so I went through some of the just the top lines earlier when I got back, and I guess I would say I'm not surprised. I mean, that's kind of, I was saying last year, even after the big beautiful bill was passed in July, there was a decent chance that they're going to propose very much the same thing in the next budget, and it seems like they've done that. Now, there are a lot of details, and so it'll be interesting to see. It'll be interesting to see how much of it I mean, well, and again, big picture. I also mentioned this when I was showing some of those charts. We don't know if there's going to be a budget passed this year beyond a continuing resolution. I mean, I guess at this point, I think if you're just going generically into a random fiscal year, you're the odds are better that there's going to be a full year continuing resolution than what we got. I mean, it wasn't regular order, but they passed appropriations bills this year, even if they were sort of minibus style. But I mean, that's probably it's not the ceiling of what Congress can do, considering how divided everybody is. But that's a big accomplishment considering the circumstances that they were. There's still one budget that has not been passed yet. So, to be fair, there's that. But I think that this is an election year, and so that just makes it even more difficult. Although I don't know that anybody's expecting whatever happens is going to happen after the general election, and we'll see what the world looks like when we get there. So. But I mean, yeah, in terms of the proposal, I mean, I got a chance to go read a couple of stories from like Marcia Smith with Space Policy Online, and Jeff Faust wrote about that. And so as I was telling people here, I got a chance during a break while we were basically just watching the crew, listening to the Orion to Earth communications and the public affairs officer. I looked around kind of to see the different reporters that I'll check to see that have stories, and it's about 50-50. Half of them are doing Artemis II stories, and half of them are doing budget stories, and so that got mentioned. The top lines look very similar, and so we'll have to see. There's no guarantee that we'll end up with the same outcomes for the process this year that we did last year. So I think they may be reconfiguring some things. So we do have live downlink so we're getting live video that's what this is. It's essentially near real time video from cameras on the outside of the spacecraft, and we have heard they were talking about, I guess, a kind of loss of signal. It's possible again that they're reconfiguring from one of the deep space network receiving stations to the next. But I think
This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. The crew aboard Orion conducting their CPR demo, learning how they would offer CPR to a crew member in need if the need ever arose on the spacecraft. Of course, this is just a demonstration and will be used for future training for future flyers. Another consideration when we fly in space are solar eruptions. Between the Apollo 16 and 17 missions, the solar eruptions were a near miss for our lunar explorers. Today, those Apollo-era flares serve as a reminder of the threat of radiation exposure for astronauts in space, as well as technology. So understanding and predicting these solar eruptions is crucial for our safe exploration. We now have data, technology, and resources available that have improved, which enable advancements towards space weather forecasts and astronaut protection. These are all key to NASA's Artemis program to return human astronauts to the moon. It's August It's 1972, and Ian Richardson, a future NASA scientist, is watching TV when the BBC announces
the interference is caused by solar activity.
He didn't know it then, but the sun had just erupted in one of the most powerful solar events ever recorded. There was no threat to humans because Earth's magnetic field deflects much of the sun's radiation. But the explosions were so powerful that intense radiation disrupted TV signals and caused radio blackouts. So what if you were outside Earth's magnetic field? On the moon and beyond, astronauts face the risk of extreme radiation exposure. Luckily, the intense radiation in 1972 occurred right between the Apollo 16 and 17 missions, when no astronauts were in their path. As NASA plans missions to go back to the moon and then onto Mars, predicting the sun's activity to protect astronauts from space radiation is one of our biggest priorities.
One of the biggest unknown factors about going to space is the radiation hazard from the sun.
This is Ian today, studying the effects of the sun, also known as the field of heliophysics.
The sun is always emitting radiation like the light we see, but certain energetic particles, like from the August 1972 events, can be far more harmful.
To be able to forecast solar energetic particles, we need to know how the sun energizes them. The sun is made up of electrically charged particles called plasma. As this plasma moves, it builds up energy inside its massive magnetic field. This energy is usually released in two types of explosions. Flares are intense flashes of light. Coronal mass ejections are giant eruptions of solar material.
These solar eruptions send shock waves across the solar system, accelerating particles as they go.
These are solar energetic particles, or SEPs. They consist mainly of protons and possess a lot of energy that can affect satellite measurements and humans.
SEPs can bombard you with a lot of radiation in a short period of time. They can penetrate your skin, damage your DNA, and increase your chances of getting cancer and radiation sickness.
But they don't occur with every solar eruption. Only a small number of flares and coronal mass ejections create SEPs.
So we're trying to predict when SEPs form and how they travel through space.
At NASA's Goddard Space Flight Center, the Community Coordinated Modeling Center, or CCMC, is dedicated to testing prediction models. Working with global partners, they use data from NASA satellites at different vantage points and models to figure out how solar explosions behave, including how shock waves energize SEPs. And as we get better at predicting, we get more time to prepare.
Preparation for an SEP event, of which you may know that is already coming and perhaps the magnitude as well, the technique that you would want to use is to put as much mass between you and the source.
On the surface of the moon or Mars, astronauts can go underground or build shelter with local materials. But in transit, astronauts can only be protected with what's on the spacecraft.
Which means that you might have elements on a spacecraft that have multiple purposes.
NASA's space radiation specialists are testing different ways to do this. One strategy they tested on the Orion spacecraft involves crew members barricading themselves with as much mass as possible in the center of the spacecraft. Other possible techniques in development include vests that add mass and electrically charged surfaces that deflect particles.
In terms of radiation protection and radiation mitigation, the factor of time is extraordinarily important.
The sun has a natural 11-year cycle that transitions through low and high activity, which is indicated by the number of sunspots on the surface. More sunspots mean more eruptions, resulting in a higher risk for SEPs. But during this increased solar activity, the sun's magnetic field strengthens, enhancing its shield against another important source of radiation, galactic cosmic rays. These are charged particles traveling at nearly the speed of light that are thought to come from supernova explosions from within our galaxy and possibly further out in the universe. If solar energetic particles are intense sporadic storms, then galactic cosmic rays are a constant drizzle. Galactic cosmic rays are more sparse, but also much more energetic. They include heavier elements that can penetrate through vast amounts of materials. Understanding the rate of galactic cosmic rays helps us determine how much time astronauts can spend in space safely. To date, humans have only been on the lunar surface for a cumulative total of about 12 days. A trip to Mars will take 6 to 10 months each way. That means even more radiation exposure.
And so NASA is doing work to prepare for that.
The moon is going to be a test bed for us in order to be able to prepare for Mars. The more that we understand the impact and the duration of radiation on the moon, the more we can extrapolate that to the length of time that we will be spending in transit and on the surface of Mars.
You're looking at a live view of the outside of the Orion spacecraft. Specifically in this frame, you can see the European Service Module and the Orbital Maneuvering Service engine. And in the video we just watched about deep space radiation, you saw some team members demonstrating how they could use cargo transfer bags to help protect a crew from radiation exposure. That is something that this crew will test out as well. On Flight Day 8, they have a radiation shelter demo timeline. During that time, the crew will build a makeshift radiation shelter within the cabin and prepare the lockers on the spacecraft for ingress. Of course, this is just a demonstration and practice in case it were to be needed for a future mission. Orion is currently traveling 3,246 miles per hour, 125,130 miles from Earth, and 144,220 miles away from the Moon. If you're just tuning in with us today, we were expecting to have the outbound trajectory correction burn this afternoon. However, that burn was canceled as it was deemed unnecessary following such a precise trans-lunar injection burn yesterday. Teams confirmed we are on the proper trajectory to send us around the moon and bring the crew home on Flight Day 10 with a splashdown in the Pacific Ocean, so they were able to cancel the outbound trajectory correction burn, and according to Christina Cook, the crew was able to enjoy a snow day. This is Artemis Mission Control at NASA's Johnson Space Center in Houston, Texas. The Orbit 1 team is currently on console, but you'll see a lot of activity happening in the room as the Orbit 2 team comes in to begin their shift. Of course, Mission Control is staffed 24/7 while in flight with Orion. And just down the hall, we have the International Space Station Flight Control Room, which has been staffed 24/7 now for over 25 years.
Integrity Houston, comm check, back with you on DSN.
We have you loud and clear.
Fantastic.
And Houston, we are complete with CPR demo if you want to get everything back to normal after that.
We copy. Thanks, Christina.
This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. We have reestablished communications with the crew after an unexpected loss of communication through the Deep Space Network. We are now back in full communication with them. The crew reported they just completed their CPR demo. Again, just a practice of how they would execute CPR in the Orion cabin if need be. They were able to film this and will share it with the ground after their flight.
I think we're at least somewhere in here is going to be another Public Affairs Office event, PAO event. Let me go look for the Public Affairs has not published an updated feature about the flight control room and the positions in there, and so, but there is one for
and this
Artemis
view on your screen coming
1.
from a camera mounted on one of Orion's 4 solar arrays. Each solar array wing has its own camera, and this one is currently pointed back to see all of us on Earth. Wave hello, you look great today.
I'm gonna go find that reference. Yeah, I guess this will work. And there's a graphic in there too. Well, let me double check and make sure. Yeah. And so what? Well, let me post it first in chat. So what happens? So in the graphic on that page, behind the GC or ground control console, you see the control and booster positions, and those are for ascent. Those are basically related to SLS. And so what happens after, especially booster, but I think control as well, but they're basically a single shift, that ascent shift, and then they're basically into post flight, so to speak. And so the science officer for this flight is using the booster console now in that position. So from that camera that we were looking at, you see the ground control nearest to that camera, and then sort of behind them to the left is now the science, and they replaced the nameplate, so to speak. And so we'll see, I believe, what's her name? Dr. Kelsey Young. I believe she's the primary science officer. She'll be in the front room on Monday during the flyby. And I'm assuming that so we're seeing the crew. And again, I'm assuming that we're getting ready for
And Houston, we're just curious
upcoming
about
event.
toilet. Is it hands off right now?
Integrity, toilet is go for use.
Okay, integrity copies.
This live view inside Orion of the Artemis II crew.
Integrity feedback on your camera position. For your information, the top third of the flags is not visible.
Oh, they're going to move the flags. Might be a good idea. Yeah, we're getting close to that, to these PAO events on the timeline. They weren't right at what are we at here? They weren't right at 2 days, 2 hours mission elapsed time, but
and now where you're placing the flags, I can see all of them. On the bottom part of the image, I can see about midway on Christina's calves, and I can see Victor's head and the camera to the in the right side of the field of view from the perspective of this camera. Copy thumbs. Looks great. Christina is well centered in the frame.
So what do they call this? Blocking. So they're getting this set up, but they're definitely getting this set up for this. It looks like it's the same half hour or so activity block, but it looks like it's between 2 days, 2 hours, 15 minutes, and 2 hours and 45 minutes instead of right on the, starting at, going from 2 hours to 2 hours and 30 minutes, or from 2 hours, 30 minutes to 3. Yeah, it is definitely looking like that now, or it was. Sort of looking like a toenail. Oh, we're back to the visualization. I'll move this out of the way again, and then we'll move it back when we get to... I guess, fortunately, today there's been a lot of live downlink. And that's one of the things that would be interesting is what the ground track looks like now. Because thinking about it, typically the ground tracks for like low Earth orbit, you would think that you would, if you were doing these handoffs, of course, again, it's deep space network, so there's a maybe oxymoronic, but you would think you would be handing over from Madrid to Canberra to Goldstone, but it's interesting that they're handing over that way. They're handing over from what is that, east to west, essentially. Yeah, there's, I don't know about today, but I'm sure it's the same thing as, I don't even know what you call the flat Earth theory. Those people believe what they believe. I'm not sure there is a level of evidence that's going to push people off of their beliefs. And so, I mean, it goes both ways though as well. So it's like, I have not seen any convincing evidence that the Earth is flat either. So, but there's going to be some. I think it's just a question of how much of that conversation do we want to have in the middle of the mission. I'm not sure that it's a particularly productive discussion to have. That's weird. Oh, I see. That is something I do. So yeah, I think one of the things we're seeing today is the moderation bot. I'm just using default settings, and so this is the first time that, like I was saying earlier, this is the first time that I've had 6-hour live streams or 10-hour live streams, and so I need to find a little bit of time to go in and adjust find some of the settings here, and that's the problem, is just finding time. And then the flip side of it is even so I haven't changed any of these settings, but for those who remember, on launch day during tanking, I went over to the Space Center to get my badge, and there were a couple of people who had figured out the loopholes in the rules, and when I got back, I just it wasn't that hard to clean up, but it's it's the you have these extremes, and so as the other part of this is in a week. So the mission, the end of the mission is about a week from now. I think probably, well, less than a week from now, but I mean essentially a week from now, and after that, I don't expect a lot of 6-hour long live streams until, I think optimistically, that would be next year for Artemis III. I don't know what, can't think of anything. I can't imagine there would be anything else. And we'll just have to see. We'll have to see whether Artemis III happens next year. But yeah, it does seem like the I mean, I for the sake of a lunar landing in the near term, I hope so. I hope we are going to see either, what you would call, so the Starship propellant transfer demo is definitely an HLS demo. I don't know. I guess by that logic, which is somewhat mushy, the Blue Moon Mark I Pathfinder is a kind of HLS demo as well, although I'm not sure how that's positioned. And we still don't really have, it's harder to see, since we don't know what their accelerated lunar lander proposal looks like. pardon me, it's hard to tell. It's hard to tell the relationship between that cargo lander and whatever their proposal is. So, but I think that will be considered a milestone, and I know that in the case of both of them, they are still targeting this year to do that. But I also don't expect to be doing a 6-hour live stream for, I don't know when we're going to, see or something like that. But I did, yeah, the NSF folks were talking about, I don't know how, apparently he posted multiple times, which I think is a little different, although it's probably not totally relevant either. But it'll be interesting once Starship starts making orbital flight tests, and then that will be, I don't know that we're going to have wall-to-wall coverage of that. I know NSF will definitely have wall-to-wall coverage of that, but I don't know whether it'll be interesting to see how SpaceX handles that in terms of, it's the current flight tests, the current single orbit flight tests are actually kind of, it's a very digestible flight test. It's only, you have several hours of countdown, but not nearly as many hours as for SLS. And then you just have, an hour, 15-minute long flight test, and you're done. And there's a lot of visual spectaculars in there. But when they start flying orbital flights, I guess it's going to be a question of, that's going to be one of the first. It will be very interesting to see how many orbits the first Starship that goes orbital can make. Yeah, no, I have not. I haven't seen any. I haven't seen any RFPs yet. And I think again the part of the problem is that are they within the authority of the existing legislation? I did see in Jeff Faust's story for Space News about the budget request that they're formally, I'll have to go back and look at how he phrased it, but that they're formally asking for that gateway to reprogram those gateway funds. I think it is pretty funny though, because they are still liquidating the gateway assets to use for other things. I think maybe one of the reasons that nobody wants to talk to the media about some of these gateway assets is because they may be sort of in limbo. So they want to use the PPE for that. What is it? The SR1 free? Is it SR1 Freedom or Freedom SR1? But they want to use it for that. But I don't know if they have they gotten the authority to proceed to do that yet. That's a good note, so to speak, from Region 7. I'll try to do that because I am just reading I'm just responding to chat, so I'll try and state the question before I respond to it. Let's see where we were. So Alfred Morgan Roth is noting, accelerated lunar lander and billions cut from the budget. Well, the thing is that they're cutting the science mission directorate budget, but they're increasing the commercial lunar budget. So it's very similar to the fiscal year 2026 budget request. So they are they're reducing the SLS budget. They're reducing the exploration ground systems budget, which makes sense because, they just canceled the main upgrade. I think from what I've heard, the other SLS upgrade, the Bolay upgrade, is still, I guess, kind of in limbo. So it's not. I haven't heard them say it's canceled or they want to cancel it or they've stopped work on it. But I also haven't heard, I haven't heard a tremendous amount of encouragement in terms of continuing with that either. But again, to be fair, I have not heard anybody saying that that they've stopped work. And the flip side of it is we see that we just heard the program manager for Exploration Ground Systems, Sean Quinn, say they stopped work on Mobile Launcher 2. I don't know that we've necessarily heard that for Exploration Upper Stage, at least not officially, but I think we have heard sort of behind the scenes. But they're reducing that money within the Exploration Directorate budget, and that money's going into investing in commercial lunar activities. Now, to be fair, I don't know that it is going towards accelerating the lunar landers, but then the wrinkle to that is I don't know that money is the problem for the lunar landers, because Musk and Bezos have access to more money quicker, faster than they'll get it from Congress anyway. So, and again, the bigger picture thing is is SpaceX or Blue Origin, is their problem that they don't have enough money at hand, that they don't have enough of an R&D budget or a financial commitment? I'm not sure that that's the case. So it's yeah, it is definitely an interesting thing. And so the science, as I was saying earlier, cutting the science budget the way they cut it is just that, in less than 3 years, we could have a new presidential administration, setting aside the general politics and all of the messiness. But we could have a new administration. They could change their mind. They could decide to cut another directorate in half and double the science budget. So, there's that. In fact, I believe that was kind of how Obama approached when he canceled or proposed canceling Constellation, and just essentially, there was no replacement for it, but they were looking to, in that case, that administration was looking to increase the science budget. So they were doing the opposite of what's happening here, which is they're taking money from science to some extent and increasing the exploration budget. But again, it's that funny thing of they're also cutting the legacy government programs and moving towards commercial services. So the question is that Earth in the visualization background? I think so. I think it's, again, I don't think it's to scale, but yeah, we'll see. I mean, some of these things. So the Mars mission, it's going to be interesting to see. Congress did cooperate with Mr. Isaacman on Exploration Upper Stage and Mobile Launcher 2, and so now it's going to be interesting to see if there's some additional goodwill there, and that if he will be able to convince them. Because he's going to have to sell this budget now, I think. We'll see. But I mean, that's the way it's been in the past. The administrator is the point of contact for the budget. Now, whether or not he was the one that wrote this budget, I don't know that that's necessarily the case. It does seem like this has the same fingerprints as last year, that this is the Office of Management and Budget. Their fingerprints are all over it. But that's neither here nor there. It's really ultimately, it's what happens, just like last year. And to be fair, there was some of the things that happened within the Science Directorate, were not undone by restoring the budget. So yeah, but I mean, it's the same thing it's the same sort of general observation for Artemis. I know I saw comments to videos over the last 18 months, 2 years. It's like, wow, it seems like a mess. It's you really get a sense of the sausage being made, but that is just the way it is. It's going to be like this certainly for the rest of the decade, if not in perpetuity. So I think at this point we're waiting for a public affair, a PAO event essentially. So some more media interviews. And so we're talking, I'm going through some comments and questions in chat. So Alfred is again talking about SLS making a good standalone proposal for itself. From its performance on this launch, yes, but I think the issue in the past for SLS has been the cost and then the flight cadence. The how often it flies. So if it was to meet the schedule that Mr. Isaacman has laid out between, for the next three, for Artemis 3, 4, and 5, then that would make a good half of a proposal. But I think the budget request documentation that was released today says they will allow, SLS air quotes, and I assume that means the prime contractors for SLS. They will allow those, and Congress wrote that into one of its accompanying reports. So it's basically just following that direction. But anyway, the point being, they'll be allowed to offer SLS and propose it to compete for this commercial lunar transport contract. But the problem is, are those companies willing to basically go sort of full skin in the game, so to speak? So they would be going from having, for the most part, almost no financial risk to having full financial risk. And so, I mean, it might be unfair, but it's hard not to look at Boeing with the core stage for SLS and Boeing with Starliner. And so the question is, are those primes willing to invest? I guess it's hard not to say, if Boeing was to invest in commercial SLS the way they invested in Starliner, that's you're more likely to have a Starliner outcome than an SLS outcome. So even though SLS is high cost and hasn't flown enough, it has performed very well when it's these two launches have had excellent performance. Can't really say that about Starliner, at least not yet. Yep, I believe so. Jay Pierce asking, is that Earth? Yes, that is Earth. Unless maybe my feed locked up. I think it's still Earth, or it was. Let me double check, but it should still be Earth. We're getting the same view from the same solar array camera. That's fair. In the comment about I will first believe about Earth being flat. Essentially, it's like it's the sort of when pigs fly. It's like this thing will get done when the Earth is flat. Oh, okay. I mean, it's more about the joke of pigs flying. I think we're using that analogy here. I did not see that, Joker. You're talking about the Halo module being converted to a lunar base habitat. Essentially, it's pretty small. I guess it could be repurposed as a closet. I guess I will be surprised if that actually ends up happening. And again, it is a fair criticism to say what I don't know. It is the SR1 Freedom concept it's a tech demo, but where is it going after that? It does end up being it could end up being a one-off, and then it serves the political purpose of liquidating that asset. So, but I mean, again, to be fair, it does seem like Jared's got buy-in from Congress about Gateway and converting that to a lunar base, or at least enough of a buy-off. And so we'll see. And the other thing I was going to say is we heard some statements from ESA folks, European Space Agency folks, before they came out here and heard the proposal directly. But since then, they've sounded supportive of the moon base. So I don't know of anybody that's going to publicly object to this. Yeah, I'll have to go through it. It's, again, it's the same thing as the SR1 Freedom render. Those are easy to do. And so if they miss their December 2028 transfer window, and of course it might be longer than just a than a month. But if they miss that window, then we're looking at what? Early 2030? No, early 2031. So it's like at some point it'll be interesting to see. It's like how long are you willing to sustain a tech demo to fly it? we'll see. It's gonna be interesting. The longer that, or the quicker that they're able to demonstrate progress and actually fly things, is going to help their case. So it's going to be important for Artemis III to fly in the middle of next year. So Joker's asking, was anyone else shocked by the ages of the Artemis II crew? I guess not. I don't have those handy, but I feel like I saw those at some point. I guess maybe I'm just so old that everybody seems young now. It's like all of these, I remember being a kid and, the astronauts were all, really old people, and now they're all much younger than I am. I wonder if they replan some of these events and maybe put together the PAO event, the regular PAO event with the Canadian Space Agency PAO event. We saw the Canadian flag up on the display there earlier. The question is when is the Artemis? When do we think the Artemis III crew will be announced? We heard Jared Isaacman talk about. It wasn't, again. He was just kind of. He was trying to. He was making the point that the crews shouldn't need to be named so far in advance. I think, again, I'm sort of paraphrasing, but what was interesting was he just, again, I don't know that it was necessarily well thought out, but he talked about 12 months, like naming the crew at 12 months, and then that would be okay. And so that sounds reasonable if what they're talking about, if they're talking about going this fast. So I think that's contingent on, if this mission continues to go as well as it's been going.
This is Artemis Mission Control.
Then
here at Johnson Space Center
maybe
in
it would
Houston,
be about
Texas,
July.
The Orbit 1 team is handing over to the Orbit 2 team, now arriving on console. A live look inside Mission Control. We are now 2 days, 2 hours, and 35 minutes mission elapsed time since Orion launched atop the Space Launch System from Kennedy Space Center in Florida. Our Artemis II crew is well on their way to the moon, now 127,840 miles from Earth and continuing to grow as the distance to the moon shrinks, currently 142,294 miles away. This a live view from a camera on the solar array wing on Orion, looking back at the spacecraft, and over there on the right side of your screen, home sweet home, our planet Earth. Earlier today, we were expecting to conduct the outbound trajectory correction burn. However, because our trans-lunar injection burn yesterday was so precise, that outbound trajectory correction burn today was canceled, considering it not needed. As the Orbit 1 and Orbit 2 teams hand over, I am also handing over the public affairs console to my friend and colleague Anna Schneider. She'll be continuing our live coverage. Again, we're here 24/7 throughout the mission, all the way through splashdown and recovery of our astronauts.
they have better staff than I do, so I was thinking to hold on to see when this PAO event is going to occur, so I'll hang on for a little while longer, but pretty soon I'm gonna wrap up this stream. We'll just see what happens with the. I'll hang around here for a few more minutes just to see when if we get a better idea about when they're going to do this stream. So again, going back to the question about when the Artemis III crew might be named, if things still look around the middle of this year like they've got a shot at the middle of next year, then maybe we'll see that, or maybe we'll see it sooner. I think that we were thinking, before everything sort of was reset, that would be a big indicator about when they're ready to fly Artemis III, whether it was a lunar landing mission or the one that we have now. So if they don't announce a crew right away, if they don't announce a crew in July, that's probably not such a great sign. So like if they announce the crew, or if we back up, let's say they announce, this mission will be over in the next week or so. Let's say they announce the crew in June. It would at least suggest that there's still hope that they can fly Artemis III in about a year from then, or July. But if we haven't heard about a crew and we get to the end of the summer, that's probably not a great sign. But it always kind of made sense that they were going to wait until this mission happened and was completed and what the outcome of the mission is before they would name the next crew. Just because it's the second of the demos, it's the crew demo.
Houston Integrity, can you please verify toilet is available?
Integrity toilet is available. Go for use.
Thank you.
Yeah, I think I'm not. I don't know what the disposition of a Vulcan Heavy would be. So Joker's asking about the payload performance. You would need something like that, because I think the only way for Vulcan to get Orion to low Earth orbit would be with a lot of these supplemental SRBs, and under the circumstances, that's probably not such a great look. I think you're looking at New Glenn or Falcon Heavy. If Vulcan Heavy was a concept, I think that, again, the problem is I'm not sure that's enough business for that development. It's like if the business case for Vulcan Heavy, which is probably why it's not happened, if the business case for a tri-core, triple core Vulcan is the only thing that's out there that needs it is Orion, that's probably a tough business case, I think. So Labyrinth Mike saying, it would be better to assign them as soon as possible. It's definitely, I think that's the previous philosophy. They were talking about, the problem is the previous philosophy was no later than about 18 months before the launch. They were talking about, 18 to 24 months before the possible launch date. And then in that case, and so by that thinking, then, as you say, that's the problem. By that thinking, there's nothing wrong with it per se. It's just they should have already named the Artemis III crew before Artemis II launched, and they weren't, for whatever reason, weren't willing to do that.
Houston, just wanting to let you know that we are going through our flight control room handover. I am bidding you farewell and appreciate getting the opportunity to support you thus far. And I'm leaving you in the amazing, capable hands of your favorite CTO. Have a good night.
Good night, Chris. It was a great day working with you, and safe travels. Enjoy training.
Oh, that's interesting. So what's her name? Jackie, I think, is going to be the Capcom on this shift. The CTO being the chief training officer. Jackie, I'm probably going to butcher her. Mahaffey? Ugh. Something like that. I'm butchering her last name. But I think that's her name. We'll find out very soon from the public affairs officer. I don't know. The question, will Congress really pay for a moon base and a low Earth orbit space station at the same time? It's a good rhetorical question, because I don't know that there's an answer for it right now. Yeah, I think the crew's been asking about that today, because Mission Control has said a few times that they don't want the crew to use it. They don't want the crew to use the toilet when they're dumping it. So it may not be a good idea just in general if that's the case. And so, but maybe it may be that plus or some other things as well. So that's also certainly a possibility. But I know they were asking about it earlier because they didn't want the crew to be using it while they were dumping the tank. They may not. I think the problem is that for solid waste, actually, I think, well, the short answer is they're not dumping it overboard.
Integrity, Houston, voice check on 1. We're setting up for a FAND DFTO.
We missed that call. Houston, can you repeat?
Yeah, we were doing some setup in prep for the sat mode DFTO and needed to do a quick voice check, and we had you loud and clear.
We have you the same, and I have 21.1.10 up on DU3 lower, and I am ready whenever you are. Please give us a call when you're ready.
There are, I believe they have. I'd have to go look up what they're called, but they have basically.
And Victor, we copy you are ready for the DFTO. As we mentioned earlier, we'll delay it about 30 minutes from the start. So 20 minutes from now, you can expect a call up that we're ready to get going.
That sounds great. It's good to hear your voice, Jackie. How are we doing so far?
It's great to talk with you, and doing great. Keep it up.
Hey there, Jackie.
Hey, Jackie. It's so good to hear your voice.
Mojave.
All right, so there's a pronunciation of her last name. She was a chief training officer, and so all the sims and all the scripts that they did to, hard coaching and so on, she was in charge of all of that.
Houston, integrity for acoustic monitor question.
Go ahead for acoustic monitor.
Hey, Jackie, I am doing my activity for the DFTO of the toilet acoustic monitoring. It's from earlier today, and the acoustic monitor is acting strangely. The battery was not indicating low. It was a yellow outline with a green interior. However, the acoustic monitor turns itself off often. It's hard to get past even the first menu or into the recording. I think I'll go ahead and try changing out the batteries just in case, but I wanted to let you know in case you have any ideas.
Okay, Christina, we copy on the acoustic monitor. We agree that trying to change out the batteries is a good first step, and we'll think about whether we have any other advice in case that does not work.
Copy, thanks.
Houston, integrity for AGA and exercise.
Go ahead.
Hey, Jackie, confirm you all are ready for Jeremy to start his exercise block.
Okay, they had to have rearranged their schedule a little bit, which is not, again,
Hey, great
happens
question.
all the
Thank
time.
you for checking. We still have a couple of things to configure before we're ready for active exercise.
Okay, if you're ready, I'll give you AGA readings, and then you can call us when it's time for exercise.
Now the big object.
Send it.
The big object on the left is Orion. It's the aft end of Orion. The object on the right is the crescent Earth.
O2 is 2.0,
So-
O2 19.7. Cabin pressure is 14.1, and temp is 76.1.
Houston copies.
So that was Britt in the chat asking about the outside view. This is the inside view of the mission control center, the white flight control room. Now we've gone to, they're checking, I guess they were going to switch back to the outside view.
Good evening
Oh, dear.
from Mission Control Houston inside the Artemis Flight Control Room. I'm Anna Schneider with NASA Communications, and the Orbit 2 team of flight controllers has recently come on console and have completed their handover with the Orbit 1 team. The Orbit 2 team on console is being led by Flight Director Paul Kanya. And next to the Flight Director there on your screen, you can see the Capcom or capsule communicator, who is Jackie Mahaffey, and she is the individual that is communicating directly with the crew on board the Orion spacecraft as it makes its way to the moon as part of the Artemis II mission. Jackie Mahaffey also served as the Artemis II training lead, so she has worked pretty closely with both the crew and the flight control teams as they prepared for this Artemis II mission. We are now 2 days, 2 hours, and 54 minutes into the Artemis II mission, following a launch at 5:35 p.m. Central, 6:35 p.m. Eastern on April 1st. The Orion spacecraft, which was named Integrity by its crew, is currently about 128,000 miles away from Earth and has about 141,000 miles between it and the moon.
HHP views, Jeremy is about to start exercise. He's okay with that. Up to you, though.
We copied. Stand by.
So the flight director there was the Inco console is off screen to the top upper right here. So he's just
And you just heard some communication
talking
there from NASA astronaut Reed Wiseman, who is the commander of the Orion spacecraft, down to the team here in Mission Control Houston. They have been discussing some upcoming exercise activities. So on the timeline, CSA, or Canadian Space Agency astronaut Jeremy Hansen, is scheduled to complete his daily exercise, and then Christina will complete her exercise as well. The crew uses a device known as the flywheel on board the Orion spacecraft to complete that exercise every day. While Christina and Jeremy complete their exercise, NASA astronaut Victor Glover is also scheduled to complete a SATBAN, or a search, acquire, and track DFTO, or developmental flight test objective. And then a little bit later in the day, NASA astronaut Reed Wiseman and NASA astronaut Victor Glover will also complete some checkouts of medical devices. And then all 4 crew members will work to complete some pre-lunar flyby cabin configurations as they continue on into their day.
So this toilet has canisters that can be replaced, but those for the solid waste. And so they talk about low residue
currently on your
diets for
screen,
a reason.
You are seeing a look at the Artemis Real-Time Orbit website, or AROW, AROW. This website is available to the public at all times at nasa.gov/trackartemis. And we provide this view when we don't have live views from the Orion spacecraft itself, but using this view, you can see the real-time data and telemetry coming from the spacecraft.
And so that was one of the things that having a module like Halo is it just having some additional volume is that they don't dump this overboard.
Integrity Houston for timeline, big picture this afternoon.
And so they have the ability to, put that trash in another place would be great.
Hey, we are wrapping our arms around some of the different DFTOs, the maneuvers that they require, the solar array configs that they require, and the fact that we have shifted the S-band DFTO a little bit relative to the planned exercise. So bottom line, we are not going to go for any exercise prior to the S-band sat mode DFTO. And during that DFTO itself, we go to VLDR, so we do not want the streaming setup from Orion Integrity, because we don't have the bandwidth for it. After S-band sat mode DFTO, there will be a bit of a window to get exercise in, and then once we head into the EMERCOM DFTO and D5 camera imaging maneuvers, we will need to stand down from exercise again. How copy?
Copy all.
All right, and we still expect to pick up with sat mode in 10 minutes.
Okay, we copy. Standing by for sat planning mode DFTO in 10 minutes.
All right, so it seems like the next couple of hours at least are going to be a lot of development flight test objectives. And so I think, and we're probably not going to see the crew, although we'll continue to hear from them. But Jackie Mahaffey was talking about they're going to be doing an S-band test, and she's talking about being bandwidth limited. So I have a feeling we're going to be stuck with this visualization for a little while. And so I'm going to go ahead and sign off on this stream for flight day 3, and we'll come back again tomorrow. I can get I might be able to get a few extra hours of sleep on the front end tonight. I'm going to cheat and go to bed probably before the crew does, and then get up before they do. And then I'll just have to figure out how to mute the wake up call tomorrow, midday tomorrow. But another thanks again to everybody for hanging out in the live stream again. I apologize for what is it, Nightbot being a little bit too aggressive with some folks. I think some folks were genuinely just genuine with some all caps things and genuine with some lots of symbols, and so I need to look for some time to see how easy it is to tweak those parameters in moderation bot. So, but I appreciate everybody who's been hanging out here today, even while I was gone. it does help the channel, and hopefully I will be able to do a little bit more traveling, because what it seems like now is that after Artemis II is complete, I may be able to chase some of the Artemis III hardware out to Kennedy Space Center at some point. So hopefully we'll be able to do that a little bit. It actually isn't necessarily going to be that far enough into the future. So the plan for tomorrow is it's going to be similar to today. There's going to be more flight test objectives. They have an outbound trajectory correction maneuver scheduled. They may do the same thing. They may just roll that up into the one on what would that be, Sunday. But it's going to be a lot of the same. There's no major maneuvers. There are a lot of flight test objectives or development flight test objectives. So it's going to be similar to today, Flight Day 3. The next, the next big day of the mission is Monday, when that's the lunar flyby day. But I'll definitely be back here. So I'm planning on staying in Houston through the lunar flyby, and then I think we won't get an opportunity to speak with some of the science folks and the NASA leadership until the next day, just due to the timing of when the lunar flyby is going to be. It's going to be late in the day, so to speak. So they wouldn't be able to do a briefing until late evening. So they're just going to postpone that until Tuesday. So I'm going to plan on being here through Tuesday, and then I'll go home to the Los Angeles area, and then that actually puts me in a good position to go down to San Diego post splashdown when the spacecraft arrives in the port there. So that's kind of the tentative plan for the next week or so. But I'm going to go ahead and sign off this stream, and I'll come back tomorrow morning, and we can do more questions, and follow along with the live downlink. And we should be getting pretty close tomorrow to when Orion is closer to the moon than it is to Earth. And it will just keep getting closer and closer to the moon over the next, 48 hours and more than 48 hours. We're less than 72 hours away from the closest approach now. So we'll come back and continue to cover things from day to day through the lunar flyby. So I'll see you all tomorrow morning.